and this session is being recorded. So thank you. By the way, just collecting some quick feedback on the past sessions. Give me a thumbs up, thumbs down on the chat, or just speak out if you like, and tell me how are we doing. That's a quick thing I want to check quickly. Like what have we done up until now? How are we doing? Thumbs up, thumbs down, or just say something.
I will say doing okay. Some of the examples on the website are missing some stuff. Um, I saw some of the videos have like a PowerPoint. Um, do you have like a PowerPoint? And I don't know if for the future that when you go through some of the concepts, it may be easier that you already have them on a PowerPoint and you're not, or at least for me, scribbling on the whiteboard so we can see them, and then you move into doing the exercise or going somewhere else. Probably that may work a little better, but I'm good until the moment.
Okay. So for the videos that might have some slides, I think I have a place where all the related PowerPoints are kept. I just will paste that link over. So let me just go there and grab those links for you. It should be on the slide share. I have most of these slides already available. So I'll just grab that link and paste it in Slack chat. So that should give you corresponding presentation links. And just getting that right now, getting logged in. Okay, home. Where is my collection of slides? Topics, my clipboards. No, where is my slide decks? Okay, I must have messed, but there is a place where I have kept it all in one place. So I'm just trying to identify and I'll grab that link at some point and paste it in the Slack chat where all the decks that I ever created are available there, and so you can read that. I'll give that link to you. Thank you.
Okay,
The other
thank you.
in terms of the uh, the exercises that we have done, uh, are you running into any issue in terms of not able to successfully complete, or any other thing that you might need in terms of actually making sure that these exercises relate to something meaningful to you? And if there is some need for you might have in terms of a project that you may be working on with a future client, future customer of yours, or something that you want to have with a current customer, depending on the nature of sensitivity of information, we will honor all that. But if there is something that you want to bring up and want to discuss in confidentiality, even just with the HDS group, you can do that separate in a separate session. And what I want to be able to say that is, let us build something, especially in the third segment. We have the architecture segment, which is where we have this particular portion. I would like to keep that portion focused on building something useful, something meaningful that may relate to what you have in mind for each one of you. And specifically with HDS, if you have a particular project, I would like you to take that on, and we can do a separate HDS only session if you like. But in this segment, we would like to build something that is relevant from what you find interesting from your business perspective. That's the idea behind this course. It is more of a consultative engagement in this section, in the architecture section, which is the third section that comes down at some point. I don't remember the exact dates, but I think you have the dates with you. So with that in mind, keep that in focus, and let us build something of interest. At least build the concept, if not write code. At least build the concept, and evolve in terms of at least come up with an architectural blueprint of what would it shape like for a given problem, for a given product, for a given situation you might have for a customer. And that is completely up to you from your standpoint as to what do you want to actually take on. So keep that meaningful, keep that relevant to what you're doing, and let us build that in this particular segment when it starts. Having
Okay,
said,
so one of the things that it was interesting was we are doing a lot of stuff for public cloud. It will be good to know if how much of that really we can bring internal. An example, I tried to go through the Terraform website and some of the other ones to see how to really run it, let's say on a VMware environment or Hyper-V environment or a local OpenStack and couldn't see that they have hooks into that. They are all those external clouds may have something else on top that is what providing the connectivity to be able to have all the automation. But if you know of some of these things, so let's say if there's a Heroku equivalent that runs on premise, that we if we can go through it, fine. If we cannot, well at least that you can say, well, this may run on premise because that may be also good to know how some of those because clouds are there are a lot of different clouds. So there's a lot of stuff that is outside, but how to also if you need to build a hybrid cloud, so you need to have some that are internal and that will connect to the external.
Right. And I think I would like to paraphrase what Carlos just said in a way that I understood. So correct me if I'm wrong, but here is what I understand, at least from the perspective of HDS Group. The idea is to do your business, which is to sell the underlying infrastructure needed for somebody to build out a private deployment of their own cloud. We can call it a private cloud, or we can maybe mix and match with a hybrid scenario. In that context, the question that Carlos is bringing up is like we are discussing most of the time we are discussing public cloud, and that is true and correct. However, all the concepts, and I'll repeat, all the concepts actually apply to any cloud, whether it's private or public. The reason why we are using public cloud primarily because that's the most easy way for us to just access easily quickly. But as you will probably recall, most of our discussions has been focused around bare bones machine. So we just don't go. So if you go look at this example, they have a ton of services, and these are all add-on services on top of basic infrastructure. And I try to understand what would it take to build out our own infrastructural based services based on our own hardware. So from our own hardware perspective, the idea is that you can then take those similar concepts and apply that to say OpenStack, VMware, Hyper-V, whatever that internal customer might have in terms of private deployment. Is the idea is to take core concepts from public cloud examples and see what we can do in any cloud, whether it is public or private. That really should not matter. Almost all of the services, absolutely all of them, will work on a private cloud also. You just have to enable it in a specific fashion and limit it carefully in that way. And so we keep bringing that up. So I'll try to give analogies or examples of as to how will you take a similar concept and apply the same thing if you would have a local infrastructure deployed in OpenStack, Hyper-V, or something like that. So that is what I will keep doing as I proceed, and that's good feedback. I would keep that focused on the primary business motivation that at least HDS team has is to make sure that HDS business is successful, and that involves underlying hardware. And I get that, totally get that. Cool. Any other thing before we proceed? Or you don't have to give right away. You can chat, talk, give me feedback, give me Slack chat feedback anytime. Call me, whatever you feel like. Anytime you have an idea, just feel free to share. I listen and I actually actively incorporate your suggestions. So I will continue to do that. Having said, our goal today is to actually understand what would it take to completely and very carefully, meticulously build a private cloud. And since we do not have equipment available right here with each one of us right now, I would like to use this example of Amazon Cloud as a cloud in a private VPC scenario. And so what I intend to do is actually open up my whiteboard. So I'm switching my screen and bringing up the whiteboard here. And in that whiteboard, what I'm going to draw is an illustration of what I intend to do. And from an Uber perspective, my idea would be to actually build out an infrastructure, some kind of a virtual playground. And this is going to be our island. So this is going to be like an island. And in that island, we have, deadly sharks outside. And these deadly sharks are going to, destroy us. And we live here on the mainland, right? This is the mainland. And so we are going to go to the island, and we want to not get eaten up by the shark. So this is me and I want to go to my island network. This is where I have my entire network. And the only way I can go there is to actually go take a boat or go through underground tunnel and then reach my island. And that's the idea, where I will have my machines, my networks, and my entire cloud componentry. I will have it sitting all inside that island network, and I continue to want to go there, but not get eaten by these deadly sharks that are infested all along the island area that I have. And that's the scenario we want to build. We want to keep it completely isolated with these sharks, so nobody can actually go there without permission, and we should be able to just comfortably go in, do whatever we want, but not anybody else. And people from outside who are customers should be able to access the public facing ports that we provide, so that those ports are free from problems. So people who are authorized to actually access should be able to comfortably walk in, access the resources. This is like public. So public should be able to allow to come into our network only through specified access points, and do the business that they want, give and take, whatever they're doing, and then that's the only entry for them. For other people from any other place should not be allowed. So that's the kind of conceptual framework we are trying to build. You can build this same scenario in a private situation, in a public situation, or even in a public cloud, in a virtual private cloud. So here is this example. There is this VPC section in Amazon that just readily gives you a button to create, like start a VPC, and there are 4 choices, 1, 2, 3, and 4, and we'll quickly go over these. But that is not what I want to do, because I want to actually carve out a design that I would like to have for my customers. So my enterprise customers would like to have a specific thing laid out in a very specific manner, and I would like to establish that. And so how would you actually enable the scenario that I'm illustrating in this whiteboard, which is to create an island network and keep everything self-contained very nicely, and have us from the mainland go there with a tunnel, or the names I used the last time was this thing called tunnel, or also called bastion. So variety of names people use. And then machines inside M1 and M2, they will be able to go outside through a NAT device. And so these techniques, I want to make sure that you probably understand these already. But a very, very simple analogous solution to this entire problem that all of us almost have in our homes is that in your home you have this, the router company, the company that gives you internet. Like some of you are lucky to get FiOS, and I'm jealous of you. I have this Comcastic network, which is available to me, and so these companies give us what is known as public IP address, basically. They give us that in form of a router or some kind of a modem, and then a router. That router allows us to then translate that into a private IP. And so this private IP will have a DNS server internal that will give us IP addresses, and that's what we have. Some of them are Wi-Fi connections, some of them are Ethernet connections. And so this is what the typical scenario we have in our home, where this gateway that we have to the internet is actually protecting our internal boxes from public access. And that is the conceptual model. So think of this as an island in which you happen to live here, but in the virtual private cloud, you actually live outside in the mainland. And so you are away somewhere here in the mainland, and your island is actually in some cloud somewhere away, where you cannot go there directly because the company that is managing that VPC is not going to allow you to enter the building. So you have to create an underground tunnel and then go in through that, and still keep it protected, keep it safe, and all your machines, M1, M2 inside, will be able to go out to the internet through this NAT device. And that is what we will build. We'll create various subnets and have a variety of machine types deployed in various functions. And that becomes a flexible way for us to construct a blueprint to lay out our own infrastructure, whether it is a virtual private cloud or it's a virtual, a real private cloud. This name I just made up, but they just call it private cloud, not a real private cloud, but the name people use is just private cloud. And that's the concept. It applies to both these scenarios. We will just happen to be using the Amazon example today and begin what we will be doing in the context of what I just described. And before we jump to that, there are these examples available that you may have seen before. I'm just going to quickly gloss through. And the idea here is this constructs let me make it a little bigger and zoom it out. In that zoomed up picture, refresh. In the zoomed up picture, what you see is a private cloud. Inside, there is only one subnet, and that directly happens to connect to the internet through a public IP address. So that's the example here. And that's the default mode. Most people will have a VPC like this already set up in most of your accounts in Amazon. So that's one example. It's one of the crudest way to simplify your deployment of VPC. But these machines that are sitting in that public subnet are actually directly connected to the internet, and we don't want that. We absolutely do not want most of our critical machines to directly connect to the internet. So that's a bad design to begin with. Having said, bad meaning, it is still useful for some people for some scenarios, but it is not always recommended. That's why I call it bad. There is no other reason to call it bad. Having said, this is another example where we have this picture of a private subnet called out. The only way this private subnet can go out is through this NAT device, and then it goes in through the public subnet, which is directly connected to the internet. And thereby, these private machines here can also connect to anything inside in the public subnet as well as the internet outside. That's the model, kind of sort of close to what we want to build, but from scratch, from hand. If you can just select this button, it will do the whole thing for us, but that doesn't actually give us the clear idea as to what is going on and some of the subtleties involved in making sure that security is in place, your keys are appropriately placed, your tunnels and bastion machines are appropriately organized, you know how to access them, you have a very clear systematic method of reaching any of the machines inside in your virtual private cloud. So we want to build these things by hand, and you probably have seen the video series that I have here in this location somewhere. I think you know what I'm talking about. Module number 11 is, I think, what I'm referring to. So this series you may have seen. It conceptually describes the idea that I'm going to draw out and actually do it by hand right now. So this is where it begins, and that's what I'm going to begin doing. And if it is too trivial, just let me know. I'll skip portions and we'll do something more interesting for you. So anytime you feel that this is too trivial, just tell me and I will skip. So having done the other ideas here are you have a hardware VPN access to an example. So you can basically have your corporate data center connected, hook up directly through a VPN connection. This can be your Cisco or Brocade or any of those devices that you have in your data center. You basically establish a trusted VPN connection between the virtual cloud that the company is giving you and your data center inside. And a third one is basically completely isolated. It's like an extension of your private office, but out there in the cloud. So you don't have any of the cloud machines directly connect to anything outside. It is just a complete island dedicated only to your data center. It's an offshoot. It's like an extra storage place, an extra compute place, an extension of your data center out there. And that's the scenario where you can do back office processing, but none of the cloud machines will actually connect to anything outside. They all only talk to your corporate data center. And that's the scenario here. And so we will be interested in the second scenario here, but we'll build that by hand. And so the concept will be something like this. We'll add some other elements also, such as a bastion or a tunnel host. And we'll see how easily you can actually establish a tunnel and have your entire team traverse through that tunnel effortlessly. And we will do those exercises in just a moment. And so let's begin. So for creation purposes, I will not use this select button and just create automatically. That's not what I want. But instead, I will begin from scratch. And so I will go to the VPC button in the bottom right corner, bottom left corner. And here, as you can see, there is a place here. I seem to have two VPCs apparently. And by the way, before you begin, you should make sure that you're checking your region you're in. So at the upper right corner, there is this region listing. You have multiple regions. You select your favorite region. I seem to like Oregon region for no other reason than it's geographically in close proximity to me. We don't seem to have a Washington region for some reason. And in that region, in Oregon, I have two VPCs, which I think one of them is under use in in Cloud Genius. The name itself is also Cloud Genius, so I'll not touch that. But instead, maybe I'll just use a different region instead. So I'll just switching my regions to say Virginia. And in here, let us see, what do I have? I still have two VPCs here, so I can probably, okay, that one is a good one. So here I'm going to delete this VPC. And by the way, one more cautionary word. This is specific to Amazon. And you will see that in the listing of virtual private clouds that you might have in your account, please take a very careful note on this idea of a default VPC. And if it is a default VPC like this one is a yes, and this one is a no, you have to be very, very careful and do not delete. There is a bug in Amazon. If you delete your default VPC, lots of things in the exercises that we have will not work because they assume that you have a default VPC. And so the way to get it back is to actually open a support ticket with Amazon and have them mark your VPC as a default VPC. And that VPC, which is a default VPC in your Amazon, you should never delete. Although you can delete, unfortunately, but please remember to not delete the default VPC in any of your regions. So you have one default VPC in every region here. You do not want, absolutely do not want to delete the default VPC. It will save you 2 or 3 days of support case. So we do not want to delete that. There is no way to mark an existing VPC as default. Unfortunately, that's the bug in Amazon. There should be a way to just select a VPC and say right click and mark as default, but it does not exist. And they're working on it. So this default VPC, please do not delete. Having said, I'm going to delete the other VPC, this one. I'm going to delete that and create all from scratch. So this VPC that I have in this East Coast, I think it's East Coast, Virginia. So in that Virginia region, I seem to have the other VPC called CG. I'm going to actually delete that one. And that is what my plan is, to begin from ground zero. And so this VPC, let us see if we have anything. Probably not. So I'm going to just delete this. And so I say delete.
Make sure you don't have any instances running. It won't delete if you don't have any, if you have instances.
I'm sure. Yes, it will complain that you have something running. It will not let you delete. That is absolutely right, sir. And so let me adjust my screen size and let us see if there is anything. Probably not. I think I have nothing in. Let me just cross check. It's a good thing to check. So 0 running instances. And go back to the dashboard. I have only one key pair. There we have one key pair and 9 security groups and nothing else in that. So I think I'm good to delete. And so here we.
When you said that, when you said that the exercises will not work, I had deleted that VPC by mistake. It recreates a VPC, and I could do everything without a problem. I can connect to the internet, deploy instances. What can you do when that's deleted?
So if you happen to have deleted a VPC which was marked as a default VPC, then I would suggest that you please open a support case with Amazon Web Services and have one of your VPC mark as default. This is, when I say bug, the fact that you cannot do it yourself, that part is a bug. It should be possible for users to mark it themselves. Now the issue that you will run into, you can work around the issue that you will run into when you use Chef or Ansible by calling out explicitly which VPC I want to use. Every command you will type, you have to type this, which VPC I want to use. And if you don't give that, the answer is the default VPC gets selected automatically. But if it is not marked as default, then you have to specify which VPC. And that's a workaround you have to do. So it's more of a hassle. You can still make it work, but it's a hassle to specify which VPC I want to use every single time. That becomes boring. And so that's the reason why I am suggesting that you please don't delete your default VPC. That's the only reason. You can still make it work, but just for convenience, just keep the VPC alone. If you have deleted it, ask Amazon to create it for you or mark yourself as a default. That will also do. And so it's more of a hassle thing. You have to call out, I want to be in that VPC, and then you have to go really, really elaborate on And I'll give you a quick example of what I mean by that here. Okay.
Yeah, when you're gonna deploy a service, it asks you, even when you haven't deleted it, it asks you where you want to deploy it. So if you create a custom VPC, it asks you where do you want to deploy it.
Correct. It'll ask you, and the command can be very elaborate. In fact, let me go find out that command. A quick example, and
Okay.
that's what I'm trying to look up. But maybe I can do that part later.
That,
But
yeah, that's okay.
yeah.
It was just to know if there was something that is major. If it's just you have to pick the VPC, I don't consider that a problem.
So
It
here,
was just I thought that something will not work because I haven't found anything that says that it doesn't work when you delete the VPC.
yeah. So an example of that would be something like this, right? I'm opening this up. So you have to go that elaborate in terms of getting it to work. It's coming up like this. Now you look at this exercise. I have to call out, I have to use this subnet, that security ID, and all that details. This AMI number, this availability zone. You have to go so much explicitly calling out things that you want to get done, and this can be very cumbersome. And so it's more of a convenience factor that you use. If you have a default VPC, you can cut down some of the things that otherwise you have to go call out, to use this, use that, use that. This is just one command, by the way. And so this is the command to actually create a server and make it run two different roles defined here in DB master and web server. So that's the exercise we'll do at some point in the next module, next segment, which is the DevOps section. So that just illustrating that point. That's where these things come along. This is the Amazon example. And in the other one, we had this different cloud example. So lots of examples available here as well as in the write-up here. But it's more of convenience, the convenience factor in terms of what makes life easy. And that's what I try to keep, your life easy, not too complicated. Although, you can, call out specifically things by hand, like I'm just illustrating that point, in which you call this out and call that out. So you have to call this out, which VPC, and then it will work. And that's the only reason why I said don't delete the default VPC. And if you have, that's okay. No big deal. You can still work with it. Okay, so let's begin. So the first thing we want to call out is from a blueprint perspective, from an overall Uber perspective. Let me just first kill that VPC that I have. So I'm going to go kill it. And so this VPC, I have two of them. I'm going to kill the CG VPC action delete and say warning, something is attached, gateway attached, huh? Okay. So I'll go kill the gateway first. Warning, the VPC has VGW attached to it. Some time to detach it, fine, go ahead, delete it. So it'll take some time to detach the gateway and then get rid of everything that we want. And then we should be beginning from scratch. And that's our plan. And so while it does that, I think on the side, I can open another window and begin my work. Let it delete whatever it wants to. And so there we go. I'm going to open a new tab, go console, and go back to the VPC section. And here I intend to create a new VPC without using a wizard. And so I will just say that VPC and then create VPC button. So up on top, create. And this is where I'm going to name it. And this VPC I can name whatever I feel like. And literally, so I'll call it Kumo. And here they're illustrating a range of IP addresses that I can use in this particular VPC that I'm creating. Oh, not this. 10.0.0.0/16. I had something else in my copy buffer, so that just came along there. So Kumo, I intend to use this range. This gives us a very, very large segment for us to play with. And this is the upper limit. You cannot create a VPC larger than /16. I believe you must have had at least a chance to review this /16 notation. This is called the CIDR notation. And that notation I have tried to illustrate in one of the videos. So if you need that, I can elaborate further, but I'm assuming you understand this. There should be a video on CIDR, at least give you a glimpse of what it means. So basically, the smaller the number 16 is, the smaller the /16 is, the bigger the area you get in terms of IP address range. So 0 will be the maximum possible, and 32 will be the narrowest possible. IP address range, which is only one, by the way. And so we are going to go with 16. That's the kind of breadth of address space we are going to get in that subnet, in that VPC. And that's what we are going to go with. In this choice, there are two different choices, default tenancy and dedicated tenancy. The dedicated one is slightly more expensive. Some companies prefer that, so they have this choice available, but I would not go with that right now. I'll just stick to the cheaper one. By the way, VPC itself is free. There is no cost to creating a VPC. It doesn't cost you a thing. The thing that actually costs you money is the machines that you put inside. And the cost is whatever it is, like 2 cents, 3 cents per hour. So pricing, you can always see the pricing. And I think one instance is free to new users. Having said, let us create this VPC. And it is getting created. Did I hit the create button? Yes, I did. So we have now this VPC called Kumo created. And you will notice that it has an ID number, some address range defined here, and a couple of other things. So in that VPC, we literally have nothing. Let us create, the next idea is to create some subnets. And here I will try to at least create two distinctly different subnets. And I seem to have a lot of these guys. But you know what? They do not belong to the VPC that I chose. So they do not belong to any of my newly created Kumo VPC. They belong to some other VPC that I don't care for. So I'm going to basically say that I do not have any VPC subnets available to me in this particular VPC. I should filter it by VPC and say Kumo, show me only the Kumo things. And so when I do that, it should show me nothing in the subnet section. That filtering should click. And now I see that I'm looking only at filtered with Kumo as the name of subnet. Kumo is the name of the VPC, and I do not have any subnets. So I'll begin creating them. And the first subnet I want to actually create is the one that we will call it. I'm going to draw a picture again to illustrate the point. What I'm doing is creating a subnet area where I will have everything on that particular subnet. Call it like, think of it as the Canada-US border, right? So this is my border subnet. It is on the border checkpoint. Think of it like that. So it's on the border. So anybody outside entering into the country will actually be able to meet with the border officer right there. And then if they have the appropriate permissions, they can then hop in. And that's the idea behind this border subnet. It actually sits on the public gateway, on the internet outside. And any machine that you create on this particular subnet will become like a border patrol officer. Oh, they call it in this country, what do we call it? Customs and Border Protection Officer, right?
NS.
Yes.
Migra.
Sorry, say that again.
Migra.
I did not understand. I'm sorry.
That's what they call it in my neighborhood. Migra.
Migra. Can you spell it for me, please, in the chat? I like to understand that. So the idea is to have these machines will be able to directly interface with the public outside, and that's the thing called border subnet, and that's what we want to create. And so just a convention I will be using is this address space. I have 10.0.0.0. That's the convention I prefer to use. Of course, you're free to use any subnet that you want to use that IP address range, but that's the range I like to use for my border subnet to indicate. And that is my intention. So basically this portion, I would like to map it to my public facing border subnet. That's just my convention, nothing scientific about it. It's just a convention that I like to use, meaning this number I will keep changing. And in other subnets, I'll keep it like 1 or maybe 2 or things like that. And we'll do more of these exercises in a different level of difficulty. Right now, we are not considering high availability at all. We are just going simple, and then we will add high availability elements also. So we will do that and do that momentarily. Right now, we are not working with the high availability picture in mind. We're just beginning to just create something to begin with. Having said, back here in that window here, I'm going to create a subnet, and in that subnet I want to create, let us see what it says here. And here I am given a choice. I will like to select my Kumo, and then I will call this my border subnet. And then I will put a CIDR block. the block they are suggesting is exactly at what I had in mind, which is 10.0.0/24, and that's the address range that I will like to pick. And this becomes my border subnet. So I create that, and next up, I would like to switch my screen again to go to a whiteboard. And in the whiteboard, after having created a 10.0.0/24 subnet, which I call my border, I will now create an internal subnet. I will call it my app servers, if you will, or whatever. I can name whatever I like, but this is the idea that I have, is I want to put my application servers right on this subnet and have this not connected directly to the internet. I would like to have this thing connect to the internet directly, but not this guy. And so any machines that are sitting here, they will be failing to connect to the internet, like absolute fail. And that's what I would like to have, because I don't want them to directly connect to the internet. And we will enable that scenario. But for that, I would like to have this app server subnet, or rather, I'll just call it the app subnet. And I will give them an address space of 10.0.10/24. That's the space I like to give to any machine that I create in this subnet. And that's the address I would like to now, address range I would like to now use. So I'm back to Amazon here, and I'm going to create another subnet here, click. And then the idea here is I will call it my application subnet. I'll select my correct VPC I have in mind, which is this Kumo thing. And then I will select my subnet range, which is 10.0.10/24. And now I will have another subnet created. And it is getting click. Yeah, I think I hit the click button, create button. Yeah. So I have two subnets ready now. One is 10.0.0.0. What did I do? Oh, this is the VPC ID. Okay. Yeah, that's why. I got confused with the, I should look here. The CIDR block ranges, not here. So these are both Kumo, and they have this address range 10.0.0/24, 10.0.10/24. And in those two address ranges, we have two different subnets. The next idea that I would like to do is to enable an internet gateway. And so creating a gateway to the internet is like going to Comcast and asking them to give me a cable modem, please. And that's pretty much this is. You create a gateway, and so I will call it Internet Gateway, IGW. Just a name, create it. That's all there is. So we got an internet connection available to us. Now we will like to actually create tables for routing our traffic. And the route tables go something like this. And we have to actually create route tables by scratch. This table is available, but I don't want to use it. I would like to create my own table. And here I will create a table for Kumo for myself. And I will call this the border route table. And one more for the internal route table. So any machine that is on the border will use this routing table. And any machine that is on the application subnet will use the app route table. So I will create two different route tables. So this is another one, going to the Kumo VPC, and I will call this the app routing table and create. And the idea behind this routing table, I will illustrate very next and let it finish creating. And then this other one, the third one, which was given to us by default, I would like to mark it as do not use, just to label it so I don't get confused myself. And so having done these subnets, what I want to now do is carve out our routes. And so we want to go back to our, where did that go? Yes, so back to subnets and VPC, our route tables. And in our route table, we should have internet gateways, Elastic IP.
I'm getting the same thing, Nilesh. When I click on yes, create internet gateway, it seems to go through, but then there's nothing listed in that box either. I'm getting the same thing.
Same thing I'm running into. In fact, that's what I was confused about, is where is my gateway? Because I create a gateway and I don't find it. I did create the gateway myself also, and I say yes, create, and it doesn't work. Okay. Now I have two of them. Okay, so two of them are detached. So I have two created now, which is interesting. It was a crazy behavior, and that's the same thing you ran into apparently. And so what I intend to do, one of those two, is delete one of them. And so I intend to delete one of these gateways. So delete, and then the other one I will associate that with the VPC. And so this detached VPC that I have, I want to basically filter by Kumo, and I do not have a gateway yet, which is still crazy. So I'll
You
create.
should be able to create the internet gateway right from the menu option, and then all you do is you attach it to the VPC that you're doing your tests, and that's how you get internet connectivity
Correct,
going out.
correct. And that's what I was trying to do. So in the internet gateway, in the Kumo VPC, I intend to create a gateway, and I call it a new one, and then create. And if I don't see it, I would like to go back to none and then filter and see all of them. The new one, I want to attach it to the VPC and to Kumo VPC and attach. And that's how I get my VPC. This VPC is still detached, so I'll delete it. And now I am cleaning up. And so that should give me a route table with a gateway option. So I want to connect that and associate that. And so I seem to have go back to filtering again. And so I should see my route tables. And in the two route tables I have, which are the one called border and the one called app, that's what my interest is. And I seem to now have a gateway which is properly assigned to the correct VPC, which is Kumo. And now back to route tables again. What I intend to do is provide them routes and associate appropriate subnets. So let us begin with the border one first, border. And then I would like to associate the border subnet with it. So I'm going to go to the subnet association. Is my mouse too small to see, or should I make it a little bigger? If that is the case, please tell me. Subnet associations. And here I need to make sure that I edit the association and select the border subnet and associate this border subnet with the border route table. And that association can be very easily done by click edit and then selecting the border and then save. That's all there it is. So we are associating that particular route table called border with the border subnet. We just did that. And so save was successful. Now we have the subnet called border associated with the route table called border, and we are good. Let us now do the same thing for the application subnet and associate the remaining subnet, which we have called the application subnet, and save, which will associate the entire route table called app with the app subnet. So now going back to the whiteboard, what we have done up until now is that we have two subnets, and these two subnets, one is called border and one is called app, and both of them have a route table with the same name. And we also have an internet gateway, and the name is called new something. Right? Some gateway available, which is available to us. We haven't actually made any connections to it. So now let us go make that connection. And the connection I would like to have is this gateway should go and allow direct connection to the route table, this one, direct connection, but not to this one. And that's what I want to have the connectivity. So anybody who's on the border should be able to go directly through the gateway out, and anybody who is inside should fail. That's my idea. And so we'll go do that. There is a chat message. La Migra, top division of immigrant police. Run La Migra is coming. Okay, I got it. Thank you. Yeah, I am a recent citizen, so I understand. I have been an alien for so many years, more than 16 years, and now I am a U.S. citizen, so I understand immigration like many times. I've run through that, but never actually ran through La Migra, which is probably a Spanish name. I understand. Okay, thank you for that. So back to here, the idea behind routes that we have to do now. So I have set associations with subnets. That is done. The next idea that we want to do is to actually deal with routes, and we will begin first with the border check. So on the border check subnet selection, I want to now look at my routing table, which is the routes section here. and you will see that it can go through the border. In the border subnet, you already have a local route to any other machine in that CIDR range. So we can connect to any other machine internally. We have a route already, and that is called out by this notation here, which is a local route to all the machines inside the VPC. We already have a connection. We want to expand it to be able to allow anybody on the border to connect on the border subnet to connect to anywhere on the internet, which basically means 0000/0. So we would like to edit this and then add another route and allow these machines to go anywhere on the internet like this. And the only way to go outside anywhere like that is actually through click here, and you will get the new one, the gateway that we have created for this VPC. And we'll assign that gateway explicitly, and this gateway will allow us to go anywhere on the internet. That's what this 0000 means, anywhere on the internet. And so when we save that, any machine that is on the border subnet, which also happens to be associated with the border route table, can connect to anywhere on the internet like this with the 0000 defined through the gateway that we already have created. This is like direct connection to Comcast, direct connection to fiber optic cable, things like that. And so now let us switch to the other one. And here we can see that the route is telling us that it can go to any destination as long as it is a local inside the VPC 10.0.0.0/16. So this range of IP addresses, it can already connect. So I'm going to switch to my whiteboard, and the idea that we now have is we have no route to the internet, no route, sorry. But these machines that are there in this particular subnet can connect to anybody on the VPC. So that the entire range we have, which is 10.0.0.0/16, is already reachable, but nothing outside. That's the scenario we want. But that's not the totality of what we want. We still want something like a scenario where we have our application servers on the app subnet with the range of 10.0.10/24. In that subnet, we have the application subnet, we have the app route table, and that currently connects to any machine on 10.0.0/16. But we would ideally like to have some kind of a router here, or a NAT device to be specific, that will allow us to still connect to the internet while masquerading. So we want to masquerade, and I have illustrated a little video on masquerading also. This is like pretending to be that. The NAT device will pretend to be this device, but it's not actually this device that talks to people outside, talk to internet sites outside. And that masquerading capability is a core function of NAT. You probably know this already, but I'm just calling it out. But we will need to have a device that sits on the public border checkpoint and then allows us to actually have these machines that we are on the application subnet. We would like to have these machines still connect to the internet, but go through this box. We need to have a box and have that box behave like a NAT. And that box itself will sit on the border. And then our routing table for these app routing table will go through that box, and through the box will then go to the internet through IGW, or the gateway we have called the new one. And that's the idea we want to have. So for that to happen, we need a box, and that can be built very easily. And once that box is ready, we can then come back here in the application routing table, in the route section, and expand our route, and then add the box we will have. So we can add another route at that time and put a 0000 here, and then put the box address in that target. Right now we don't have anything, so we cannot put this IGW. This is like bad idea. If you put this here, we don't want that. So you don't want to connect directly, but instead want to go through NAT. So we are canceling it out right now. We will go to our EC2 section, which is here, and then actually find a way to create our own NAT if you like, or just use a ready-made NAT available to us. So one of these two choices. So the easiest one is to just use a ready-made NAT. And Amazon provides us, every cloud provider will provide us a NAT. The best way to find it is just to go search and search for NAT. And there are too many NATs available, so you can just minimize and narrow down the search to say NAT 2015. And so we still have a lot of choices, but I will stick to the Amazon choices. So the top three are Amazon choices here, and I will select at these two different machines types we have here right now. If you look at carefully, there is a HVM virtualization type here at the first item. This is HVM type, which is hardware virtual machine virtualization. The second one is also HVM, and the third one is paravirtual. The paravirtual technology is the older technology for virtualization that Amazon used to have. They still have. We want to stick to the newer one, so we are going to choose one of these two. The difference between this one and this one is actually very, very tiny. The tiny difference happens to be that this uses EBS volume, whereas this uses a special purpose IO optimized SSD device. And so this machine can be likely a little bit more expensive than this one. And we are talking really about peanuts, but that's the difference. And so having said, having understood, for our NAT purposes, we don't need a highly optimized SSD with IO optimized SSD. We don't need that. So this is probably an overkill for our example. So that's the reason why I would choose this EBS HVM, new technology HVM based machine. And that's a ready-made Amazon Linux already configured to run as a NAT device inside a VPC. So that's the AMI Amazon machine ID number we would like to use. And we'll select that and then select the cheapest possible tier, which happens to be a micro instance. And so we will just select this one, and it is not available apparently. Okay. So we will say all instances, and the T2 micro is available. T1 is not, which is fine. So we'll take a general purpose T2 micro. And then configure the details. You want to make sure that we are appropriately selecting the correct VPC, which is the Kumo VPC, not the default. The default one populates by default, by the way. That's a default. The function of default is to actually get selected by default. And so that you have to manually change over to Kumo. And then you have two subnets here, the border subnet as well as the application subnet that we created just a few minutes ago. And so we want to have this NAT box in the border, right? So we will select the border subnet. And then we want to automatically assign it a public IP. So we do want to get a public IP for this box. The default selection is actually to not get a public IP. So you have to be very careful in doing that. So I will select enable to explicitly get a public IP to this NAT box. That will allow us to get something like this. So I'm changing my screen again. And this NAT box, we want a public IP here. This IP should be public so that the NAT box can then behave like a masquerade and help these internal machines talk to the public outside. And so we do want a public IP to this box. That's what we are creating right now. And back here, we want to leave other options default, not super interesting, but we can come back to them later. And so we can just leave everything alone for now, add some storage. We are not interested in magnetic storage. We can get a general purpose SSD, which is for the same price, not much change in price there. If you go IO optimized SSD, that becomes expensive a little bit, but yeah, more expensive. And SSD is probably good. Then we go tag an instance. We will call this instance our NAT machine. So as simple as calling it that. And then I will like to describe this idea of a security group. The idea of a security group is simply think of it as, I'm going to screen clean again. The idea of a security group is, first of all, it's a group. And so in that group, any machine that belongs to the group will function like a collection of rules. So we are putting together a collection of rules, collection of firewall rules to be precise. And so if you are familiar with this Linux firewall called iptables, that essentially is what I understand. Some modification to the iptables concept in Linux is what Amazon has taken. And that's what Google has done with their own firewall implementation. So they have the idea of a firewall rule. And these are the concepts of these things come from the package called iptables in Linux. That's where firewall comes from. However, they have taken that approach and actually taken it outside the machine in the environment layer, where they control the security group, meaning they control firewall rules around a collection of machines that you mark as a group, and then associate the rules that you will superimpose on top of a collection of machines from the outside. IP tables typically run on the box level, and you can then control which ports are open, which ports are closed, who can talk to who, and what when traffic originates from one location, whether you allow the traffic or not. So there are elaborate rules you can put in IP tables at a machine level. But what these cloud providers like Amazon and everybody mostly except DigitalOcean, they don't have a concept of firewall rules from a security group standpoint, but most other providers already have this concept of a security group in which the core idea is that you get collection of a group of machines defined, and anybody, machine number one, machine number two, any number of machines that are there in that group will all follow the same set of rules. And now we will begin describing some very simple examples of a rule. The rule for, say, the NAT security group. I would like to have that rule such a way that anybody who is a NAT group member should be allowed to access anything outside. Yes. Should be allowed to access anything inside? Not really. But if you have a machine inside already, you want to have those machines allow anybody in the NAT. So you want to allow this traffic, okay. And you don't want to have the NAT coming into mucking around with our machines inside. You don't want that, so don't allow that. But have a traffic that comes from outside. There is a need for the response to come back to a machine inside, that should be allowed. So we are basically calling out set of rules for security groups. So we'll begin with a trivial sample rule set and expand it over time. But right now, back in Amazon, I'm creating a new rule, a new set of collection of rules that I will apply to my NAT boxes. There was a chat message. I'm going to quickly read that. The chat message: how can you set up NAT to use DDNS, dynamic DNS? Okay, NAT. How can you set up a NAT to your NAT? Or more specifically, a static public URL for NAT IP assigned by DHCP. Okay, let me understand that question, David. The question David has is, the concept of a dynamic DNS. So in common scenarios, the idea of a dynamic DNS basically comes from the fact that your Comcast or your Fios provider you might have will give you an IP address, a public IP address, which will change over time, right? This will change over time, and you want to reference this machine through a name, not by an IP address. And so you can enable this scenario through this concept of a dynamic DNS structure. There are many companies that provide this kind of a service. Some of them are free, some of them are not free. A very well-known one is called Zone Edit. Another one is called No-IP. There is a DYN-DNS.org and bunch of other companies. And sometimes your router, like in your homes, like this, homes or office routers that you might have. So I'm just pulling up a router example here that will be built. It will have a built-in capability to look at your security services. Where is the dynamic DNS? Here. No. Here. Where did the dynamic DNS go? Okay, somewhere here I'll look it up, but there is a way to set your dynamic DNS somewhere in my router. I'm not able to find it quickly, but it's as simple and as trivial as the idea that anytime this address changes from the company that provides you IP address, the name record will automatically get updated. That's the idea behind dynamic DNS. Now, if you have a private network where the provider actually gives you a different IP address, so in your private island you have, in your company, you have an island and you have the NAT box sitting right here, right? This is the NAT. And your internal company that gives you internet connectivity is going to give you a changing IP. It's a public IP. And you're going to get a changing public IP over every month or so. Sometimes they might change it. Sometimes they might just keep the address. You want to have a name reference to this IP address persistently pointing back to this, sorry, not this, but this box. And you can map that through a simple dynamic DNS rule. So you can have a dynamic DNS defined in a simple script you can run in Perl, Python, C#, whatever language, and have the records updated for this particular name with this particular IP address that will change. And you want to actually keep track of change here. And anytime that change happens, that you want to go back and update this record for your NAT device. And that way, anybody who is outside this particular island want to come in through the NAT and has permissions to come in through the NAT can just use the name reference as opposed to the IP address reference. That is very easily possible through a short script called Dynamic DNS Updater. There are lots of scripts already available, or I can point you to some after the session. I'll remember to make myself a note for that. And in the context of a cloud NAT, like what we are looking at here, like the NAT we are building up right now, you can actually request a static IP from this company called Amazon. They'll give you a static IP, and actually you can allocate that to a given name in Route 53 or your Google DNS, or any of the cloud providers will give you DNS. You can map that public IP address you will get statically assigned, associate that with your NAT, and keep it locked down. They will never change it. So the concept of dynamic DNS doesn't arise because it's frozen for you. And to the extent you will keep paying them the money for that particular static IP that you will get, that doesn't change. So that's a possible solution for you. Does that answer your question, David?
Yeah, I think so.
Okay, so we are going to create a new security group here for our thing that we call the NAT security group. And then in that security group, I will put a simple rule for now, just a placeholder. And the rule is to allow me from my current location to get in to that box, the NAT box, from my IP. So this is going to be my IP populated, click, and this will load up my IP right there. And you can see the /32. Basically, it means that it is my IP right now for this machine, the public facing IP for my environment. And so when I am putting this rule in place, the only person who can go into the NAT box from outside through SSH port number 22 is me. If I leave it open-ended like this, anybody who has access to the key that I will be using to get into this particular NAT box can get in. But this is too wide open. This is too wide, and so it's giving you a warning already. With the rule of 0000 allow all IP addresses, we recommend setting it to allow only to known IP addresses. So you want to limit this to a range of IP address if you like, or you select your own IP address for now, and you limit.
So this is the part that would actually change with the dynamic DNS. Like if you were going to set this up so that you could only modify it from a single place. Like if you're coming out of a NAT in your environment, and your telco updates your IP address, then you're not going to be able to manage your instance anymore.
That is correct. You have to go back here and change your security group and change this setting.
Don't you need to be coming from that IP address in order to change that?
No, you need to go to the Amazon console, right? So you don't need to go to the IP to the box to change it, but this console is available through Amazon.
So you just wouldn't be able to get in there until you come in and reconfigure the.
That is correct. You have to go either configure it like this, so you basically change your IP address in this location through the Amazon web interface, or otherwise you put a range of IP addresses in that you might have in your company, right? So unless you are traveling, in that case, this IP address will change over time. And then you have to go back to Amazon through a browser, change it, and then proceed. That will work.
I think that's why you use a Bastion host, Dave. You don't have to do all that change. You just allow access to one instance from everywhere, and then you.
Actually, Bastion. Yeah, I think I will elaborate. Let me get to the Bastion point. The point is like this. So even if you have a NAT, or you have a Bastion, or you have any other type of thing on your border, you may be in your home here today, or your office tomorrow, or maybe your vacation home the day after, and you have IP address 1, IP address 2, IP address 3. You're configuring the machine right now from your home office, and that is the address you are putting in this location. However, you might travel tomorrow and you will say, I will go to the office. And then this address is different. And you are sitting here with your laptop, and your laptop is not able to connect to your Bastion, not able to connect to your NAT, because you are not here. You are here. And so it will refuse unless you go to the Amazon Web Services, AWS console, and then go to that particular security group assigned to these guys. So you have the NAT security group, and you have to go modify the security group entry and remove this reference, IP1, remove IP2, put it here. And then you, from this laptop, can go. But then anybody in your home office cannot. And so that's why, from a corporate usage perspective, what I would do is I'll take these IP addresses 1, 2, 3, and put all of them together in form of a custom IP range. And that's the common scenario you would go. From a corporate perspective, corporate user perspective, you typically will limit your employees to VPN first before they connect. And once they get into VPN, they probably have a corporate IP address on the public-facing endpoint, which means you can then specify a custom IP address that are allocated to your corporation in here. And then whether you are, in that case, in your home or office or your vacation home, all of that is irrelevant, because you are now going through some kind of a VPN to your corporate operation, so corporate location, so corp. And then through corp, this is already defined in the NAT-SG. So anybody who's VPNing should be able to successfully go inside, because they are all representing the corporation, whether it is their office location, home location, vacation home, or travel, or Starbucks, or it doesn't matter, because they are VPNing, and you are in the company, in the corporate network, and the corporate subnet range is called out in the NAT security group. And so that gives you mobility.
Yeah, that allow you to do that, but on the Amazon white paper for Bastion host, it actually says that because the Bastion host is the only one that then you're gonna allow to come in, and you're gonna block SSH from everything else. You actually then
can you pull it up? Can you send me a link to the Bastion host? I want to read what they're saying. But I think I would like to read and just discuss that carefully later. I absolutely want to, because the scenario that I'm describing actually works comfortably, but there may be some subtleties. I want to read that, so I will do that as soon as you give me a link later. Right? So for now, I'm going to just stick with my IP and then review. And in this case, I'm going to provide it a key also, a key pair. So public key, private key pair. I will give the public key to them. And that's what I intend to do. So I'll click launch button, and then I seem to have this key already in my computer. So I will just use that key pair. If I don't have a key pair, I'll just create a new one and then use that one instead. But I have it already, so I'm going to just use it. This is the key I already have in my computer. So I'm going to acknowledge, yes, Amazon, I know I got it. I have this key in my laptop. And so I'm going to use that key, this CloudGenius PEM key that I have. So I have it. I say, yes, proceed. And so now that NAT instance is getting ready. And you can see that NAT instance is actually getting built. And you will also observe that this guy is using the NAT security group that I just assigned. It is also using the same AMI machine image VPC NAT AMI that we have asked. It is also in your VPC ID, which is this ID, which probably matches the correct VPC, which is the one we have created called Kumo. It is also the correct subnet, which we have created called border. They should actually, Amazon should update and give us the names instead of these numbers, the funky numbers. So we can also cross-check, but I'm pretty sure they're correct. So having said, our NAT is now running. However, a caution with NAT is that it has to actually be allowed to function like a NAT. And by that, what I mean is you have to go and make a change in the setting by default. It cannot function as a NAT device unless you allow and relax, and again repeating, unless you relax the source destination checking. And so that part, I'm going to illustrate that one more time very clearly. Go back to the running instances. You have only one machine here. and you have to right click on the machine and say networking, and then change source destination check, which is here. And that source destination check is enforced by default, which basically means that any traffic that originates from the same source has to be destined to the same. And that is a default rule across the board for every machine that gets created on Amazon or just about any other cloud. Unless you want to have a NAT device in which the source and destination of packets originating may be different. The NAT device is supposed to act like a masquerade, like a pretend that I am the other machine, but I am not really kind of device. So you have to change and relax the check corresponding to source destination. And that is what I'm going to do actually, is to go back to the NAT device, right click, networking, change source destination check. This is a critical step that you absolutely have to do for a NAT device. And unless you do that, it will not work like a NAT device. It will work like a device, but it will not actually work like a NAT device. That's what we want. And so we have the networking change source destination check. I will click on that now, and you will see a prompt coming up. It will say that the status is enabled. And we want to actually disable source destination check for a NAT to function like a NAT. And that's what we are doing right now. Are you sure you want to disable this check? Only for NAT, say yes. And I'm going to disable right now like this. And that's it. Now this device can function like a NAT device. You will also notice that it has a public IP address. So we need to grab that public IP address. And then you also know that this Amazon machine image is Amazon Linux, which means that the username is, by documentation, the name is EC2 user. EC2-user, that's the name. And then we have the IP address in place. So we'll use this username followed by the IP address, the public IP, and then use the private key that I have saved already in my computer. And I will be able to connect to this machine comfortably just now. And so I will check another chat message that is there. Okay, you got the white paper. Okay, I'll get back to the white paper later. So I'm going to go to the terminal right now here, and then type the same thing, which is SSH EC2-user at public IP address. And then I should pass -I option and the key that I have saved somewhere. And that will let me in. So it will say click and say, are you sure you want to connect to this machine? And I'll say yes. And then it will let me in. And now I am inside my NAT machine. You can see that by, this is an Amazon Linux machine. It is based on Red Hat Linux Fedora variation, but the machine itself is Amazon variation of the Red Hat chain of Linux. And so it's a derivative Linux based on Red Hat. And so that's what you're looking at. This device also is a NAT, so meaning NAT capabilities are built in. If you want to create your own NAT because you don't want to deal with Amazon Linux, that is also okay and possible. And I'll walk you through at some point as to how you do that if you like. However, we have successfully connected to the NAT box. What does that mean to us? So I want to come out of it, exit here right now, go back to Amazon, and then finish our routing table work. So we'll look at our route tables, which are back in our VPC section. So we'll go there. And in our VPC, we have the Kumo VPC defined, which is here. And that Kumo VPC, we have our route tables. And so, okay, come on. What's going on with Amazon today? Oh, there we are. So we have the app and border. These two. We have the border. We already have completed the routes all the way to the public internet through the gateway already. That part is done. But now on the application side, we want to expand the routes and allow anybody on the application subnet using the app routing table to go anywhere on the internet by editing that route, adding another one, go to 0000//0, and then the target. And we got the NAT target now. And this pops up because the device actually is available for us to use. So we can then, instead of choosing the new one, which is a gateway, I want to choose my NAT as the route to the internet. So if I do that like this and then save, it will allow me to go to the internet, but the traffic to the internet is masqueraded by the NAT box. You can see that this number actually matches the machine ID for the NAT device. So now we have constructed two routes, one for the border, one for the app, two clear route tables, and two clear subnets. And that is what we have currently. We have one gateway to the internet and one NAT device that doesn't show up on this screen. We have to change the screen to see it, which happens to be in the EC2 section. And so that's what we have configured correctly by now. What does that mean? Is that now we can go create any machine that we like on the list of running instances we have here, only one, NAT. And now we changing my screen again, drawing that illustration of this particular drawing that I had, two of them. One is called the border and the other is called app. Now, if you create a machine here on this one of these guys, right? If you create a new machine here, it will allow that machine to connect to the internet comfortably because it is going through the NAT box like this. And NAT itself is connected to the world outside, the gateway. And so it can go out through and through. Without this NAT in place, we never allowed it to go. So any machine that you create here should be able to go out through the NAT comfortably. And any machine you create here already connects to the internet directly. So there is no issue there. So our goal, next step is to actually... Yes.
Correct me if I'm wrong, but don't you also have to assign Elastic IP to the NAT server?
In an ideal case, yes. But you don't have to. You already have a public IP. You can just use it. As a best practice, yes, it's a good idea to have an Elastic IP here. And so it stays with you. And so as a corporation, for a big business, you would get an IP and put a name here, like nat.business.com, something like that, and just associate that name with this IP address. But you can still use it without it. And because you have the public IP, which is...
How?
Right? You got that?
No, but when you create a NAT instance, it doesn't assign a public IP. You had to manually assign an Elastic IP.
You did. Yes.
Yeah, that's what I thought, because you can't actually get out without having one.
You can. See, here we got the public IP already. We did that at the time of creation, right? When we launch an instance, we chose that we want to get a public IP, right? Like this. So let's say get this instance, and you say review and launch. So sorry, previous and previous again. I think I jumped too much. So previous.
You assign it on the first step in there on the subnet, because in your subnet, when you assign, you put it to automatically enable it. But if it's an internet subnet, it should not be automatically assigning IPs.
If it is a border check subnet, like in this case of Kumo, if it is border, the default will be to disable.
That's where I was going.
Right. The default setting is disable. But if you remember, at the time of creation of the NAT box, I chose to enable it manually.
Okay.
And that is why we have a public IP, because it was auto-assigned.
Okay.
And that is what I'm going to use. Instead of leaving it like this, which is a default state. By the way, this is the default. So you got Kumo, got border, and disable. Disable is the default. But at the time of creation, I chose like this, which gives me a public IP address already. So I have it already here, which is actually right there. And so that's the IP address that I used to connect here. Right? And that is what I intend to use for all our purposes. It's very comfortably, conveniently available, even without explicitly assigning a Elastic IP. Elastic IP costs money, and this doesn't. It works. And it is working right now. It will work. So there's no reason to necessarily buy an IP, but yes, it's the best practice recommended by Amazon. This will also work, by the way. So you don't have to. That's what I'm saying. You can. And I think it's convenience also. And so you get a dedicated IP assigned to you. You can reallocate that IP to other machines. If your NAT dies, that becomes a benefit, right? If you, for example, if you kill,
that was the other reason. That was the other reason I was going to say is that if NAT goes down for something,
yeah,
the IP address changes and you're going to have problems. With Elastic IP, at least it doesn't happen. You just reassociate it.
Yes, that's the benefit. And so that's the reason why people get Elastic IPs in corporate settings, is that you don't want to mess around with your IP addresses. And so this public address might change. If you kill the machine right now, you will not get the same one again, or you may not. And so with Elastic IP, you can get allocated. It's like reservation. So I have it already in my hand. I can just allocate it to this box versus that box, and then that's my box. And so that's the reason why people get Elastic IP address, but not required. And that's what we are going to use. Just go with this for now. And that's what I intend to use. So the construction I'm going to create next is to actually have a machine inside, internal. So I'm going to launch an instance. This time I'm going to go to Ubuntu machine and put that machine, maybe T2 small, T2 micro, one of these. And then I will say configure details. I will stick to my Kumo. And this border I will put in the app subnet. And by the way, I don't want to get a public IP. Like, do not. So auto assign, no, don't. It is on the application subnet. Don't get me a public IP. Keep it in the Kumo VPC. And then I proceed. And then I say next. I want to say add some storage, and general purpose SSD is good enough. And then we tag the instance. I'll call this my application server. And then I will configure my security groups, and then I have to create a new security group. And this time I will call it my application security group. Just a name. And for now, we'll leave it very, very narrowly focused on just one port number 22. And allow this, again, limited to custom IP. Or actually, you can leave it anywhere because nothing goes there, actually. Nobody can actually connect to it. It doesn't even have a public IP. And so the scenario that I would like to actually do is put custom. And I'll allow my NAT boxes to connect to this. So here, NAT. I would like to put the NAT security group here. That's what I want to do. So I'm trying to find out what that will be, and that's what I'm trying to pull up. So if I say NAT, there we go. So what I just did, I'll try to show you again. What I'm really trying to do is in the selection of custom IP, I don't want to go because I cannot even go like this from my home directly connected to that box inside the application subnet. I cannot go there. The only thing I can do is to connect through the NAT right now. And so I need to actually select custom IP here. And then in this box, I will start typing the name of the security group in which my NAT sits. The name happens to be NAT security group. So I'll begin typing N, and I will see this drop down. That is a reference to the NAT security group, which I have in my current VPC called Kumo. And so I can just select this security group reference as opposed to an IP range. I can do that. And what this means, anybody in the NAT VPC can come in. So application security group, please allow traffic to come when it's coming from port number 22. Allow it to come inside if and only if it is coming from the NAT SG. And that's my current selection. With this selection, I want to proceed and review and launch. And so right now, I'm going to launch it, and I'll select my same key pair I have and launch. What this just did is that it will allow me to connect. There was a question?
Yeah. What you just kind of hooked in there, so you're basically saying that the source is the NAT security group, you're saying, right?
Yes.
But that doesn't really make sense because it has to be the source has to be an IP, right? So when you're typing NAT, my understanding is that the NAT that you're typing is pulling the reference of the EC2 instance which is tied to the NAT security group, but you're not really hooking one security group to another. It's referencing the source IP address of the NAT device. Is that right?
So the way I would like to describe that idea is like this. So in my app security group, any machine in the NAT security group is okay to come in port 22. That's what I'm saying. So I'm not going by IP address, but instead I'm saying any machine in NATSG. By typing the word NATSG in the selection for custom IP.
Ron, think about the security group as a firewall policy. That's what technically it is. It's a firewall policy. So anything that SG has been applied to, it gets all those same permissions. So you can do this firewall policy. So anyone that isn't here can get access to this other security policy, so they can connect to each other.
Yes. Yes. That's exactly.
You're just calling it NATSG, but it's just that security group, so it can group. So you can have all your web servers can come to the database server, and the database server, you're blocking port 22. You only allow in port, let's say, 3306 for the database.
Yes, indeed. Exactly. And that is exactly what we're doing. Is any machine in the security group called NATSG, which follows the same set of rules that we have for firewall perspective, if you belong to that group, you are welcome to come in. If you don't belong to the group, you are not.
Okay, maybe if I rephrase it a different way then. So let's say that on my NAT security group, I have 10 IP addresses that are on the allow list to SSH to that device. Okay?
Mm-hmm.
So, and then I'm setting up my application security group behind it, and I only want source number 2 to basically come through. So if you're now referencing that NAT security group, then that's going to allow all 10 to come in.
Correct, and that's a bad idea to call this in that case. Don't.
You can combine it with an ACL.
Okay.
Yeah, if you use the name, all these 10 will go in. We don't want that. Limit it to only this.
Okay. All right.
Yeah, just be narrow. Be small is better than being wide. And catch-all ideas are bad. So this was just an illustration because we only have one. We don't have these guys, but in real life, you may not. By the way, in NAT, you probably have just 1 or 2 devices, mostly 2. And so both of these will be NAT in a failback mechanism, like a high availability NAT scenario. But then apart from that, you will probably not have anybody in the NAT SG. So it's a safe way to deal with that problem. You have both these NATs, allow them to come in, but nobody else will actually become a member of the NAT SG, because then for other members, you will have a separately named different security group. You don't need to use this particular name NATSG for any other function apart from NAT function. And so you will probably have 1 or 2 NATs in a high availability scenario. They will belong to this security group, and it's okay for them to go in here because both of them are NATs, and that's it. And
well, typically, wouldn't you actually set up your web servers, so your app servers themselves, to be accessible from the outside to serve up content, and then have your databases on a private subnet? You just have a security group that allows just access to 3306 for backend databases from the web servers, and not anywhere else. So I
will elaborate. First of all, the question I understood, the way was it is like this. So if you have this scenario where you have your application servers, you have a database, or maybe a database as a service, or maybe a database machine, one of those two. So you have a separate subnet dedicated for this. We'll call it the DB subnet. A separate subnet call it the app subnet. A separate subnet for this called the border subnet. And then in a practical scenario, you will have an application security group also for this. You have a database security group for this.
Yes.
And you will allow these guys to connect to this one through this port. and then allow a load balancer here
to connect to the app servers.
To the app servers. So you will allow, say, port number 443 or 80. Actually, 80 is more appropriate. So 80 to connect to the app server group, and from outside you will allow port number 80 access, port number 443 access, or some other ports as needed. And you will not allow any public access directly. No. And these guys will be able to connect to the DB through this database port, like MySQL port. This is, and so that should be okay. Your load balancer should not talk to the database directly. That's a no-no. You have your NAT device should not be talking to the database. There is no reason to, so you say no. And so basically you go minimal, as less number of things that you allow to talk among these subnets, among these security groups, the less you put, the better off you are. And so the less the less you expose your machines to outside or even inside, the better off you are from a security standpoint. The less number of ports, only as needed. So there is this principle of this concept of as needed. Like, this is a corporate principle also. Information is provided to you on an as needed basis, right? Many companies follow that, and so they give information to people only as needed. Not everybody knows everything. That's a corporate information principle in some companies. Some companies are very open. So depending on the company policy, the similar concept applies to your machines. You want to have the machines not unnecessarily accessing other machines, even if they are all internal. You want to explicitly allow database access only on this port for only those app servers that need to access. Other machines that might exist, like this guy, NAT, has no function to go to the database, so don't allow. And that's a fundamental way to think about it, is only as needed. You open only those ports and only those rules and only those collections that you have. And so BioBreak, yes, please. Yeah, beautiful idea. So anytime you feel like BioBreak is a welcome thing, please do that. We can take a few minutes if you're ready. Right now the time is 2:34. Let's get together in 10 minutes or so and let's continue this. So what we have done is basically created two machines. And when you come back, I will walk you through this concept of it, jumping through the NAT directly through and through one shot. And we'll do some exercises with that. So let's come back in 10 minutes. Hey, ready when you are?
Yep.
Okay. So a quick one on Carlos. If you can point me to the paragraph you're referring to, the Amazon link, that will be awesome. But I will read that exactly what you're referring to and answer that later. I was trying to find out what that reference was. So we were connected to the NAT effortlessly by just typing something like SSH and then the IP address, EC2 user at IP address, and we are able to connect, no problem. This is possible because the machine that we are talking to already has a public IP, which is this IP, and we can just go there, no problem. However, getting inside the other IP address, which is doesn't even exist in the public domain, it is only inside the VPC, there is no other way to go unless you hop. And that hop is possible through the NAT. We'll use NAT as the bastion. This is a non-standard way of doing things right now, but I'm just calling it out that you can use NAT as a bastion. It is not a best practice. Don't do that, but you can do it. It's technically possible. And so the best practice is to keep NAT separate from bastion. That's the recommended practice. The reason behind is that you want to have a NAT device purely function like a NAT and don't muck around with it, don't mess with it. And that's why I recommend that if you want to go in from outside and you want to go to the machines inside your app or your DB or other subnets, you don't use NAT, use a separate bastion. That is a best practice recommendation. And so you want to go like this from the bastion, you go in wherever you feel like. Don't use the NAT. But for right now, I'm just technically demonstrating that it is possible. Doesn't mean it's the best practice.
Nilesh?
Yes.
So you're using the NAT to come in?
Yes, you can. You can. You can technically do it. And so that's what I am illustrating is you can do it. And this is a way to save money. But it is not the best practice. Again, this is a bad, and it's not a bad idea. It's not the best practice. Not best practice.
Why not use an ELB, a load balancer?
Load balancer as an independent machine that you create, or a load balancer that Elastic Load Balancer Amazon?
Yeah, an ELB, an Elastic Load Balancer, so you can just allow the port that you need, and you don't have to manage that NAT.
Correct. I'm saying SSH access. And so for SSH access, you need to go into this machine or this machine you want to go through SSH, and you need to hop. And that hopping point, you need some machine to hop through and through, and that is what I'm talking about. So the idea, that you want to go from where you are, you want to go SSH into the app layer inside, which is not accessible. All you can do is reach the border, but you cannot go inside. So go here, you need to hop, and that hopping point can be a bastion, it can be a NAT box. Again, this is not really recommended, not a best practice. This is the best practice, is to use a separate dedicated bastion box is recommended. We can take the recommended route also just a few minutes after we finish this, but I'm just illustrating the point right now is that to hop, H-O-P, hop, to hop like this, you need to basically take a flight from here to here and then here to here. And that two-step hop is possible if you first connect via SSH this machine, and then on this terminal, you can then SSH to this machine. And because this machine can route to this easily, and you have the NAT-SG security group allowed to access this app SG, it will succeed in getting to that point effortlessly. Now, however, having one SSH connection and then putting your private key here is also another bad practice. So I would not recommend that. You don't want to give your private key even to your own NAT. Then how is the solution? Then how do you actually hop like this, like a jump from here to here? And that concept, without sharing your private key, you can enable through a technique called SSH proxy command. And that technique is defined in a file that I have placed inside your virtual machine in this folder. The file is called sshconfig, and then I have added an extension to it called example. And this extension you want to delete, and that's the name you want to keep. And that file will become an example for us to use the SSH proxy command. And what this does is that you can, once you have the file renamed, you have to rename that SSH file config. Instead of .example, you rename it to, or copy it to just config. And then you have to edit this file accordingly. And that editing, how you do and what exactly do you edit, just tiny little edits you have to do to make it work. And this command is the command we'll be using, and I'm going to open the file myself in my terminal. So I'm going to clear my screen and then open the editor to open the SSH config file. And this is how it looks like to me. In my example, it looks like this. And I have made two changes. One of them is line number 7. I have used the NAT hostname. And then in line number 13, I have used the private IP address of the internal box. That's the only change I made. In line number 9 and line number 16, I have a reference to my private key, which is accurate already in your example. You should have a reference to your IDRSA. And I'm assuming that is the key you are using with Amazon. In that case, you don't need to change line number 9 and 16 do not need change in your case. You need to change line number 7 and 13. You probably do not have line number 1 and 2 in the example, and also not 4. But line number 1 and 2 basically allow you to sustain a long-term connection with some services that happen to drop the connection if there is no traffic. And so it just basically keep the connection alive every minute. Every minute it'll kick a message and keep the SSH connection alive. That's the whole purpose of that line number 1 and 2. For right now, I'm going to hide that and just focus on what is most meaningful to us. And this construct allows us in one shot jump straight connect to line number 8 in one attempt without sharing our public key, our private key with anybody, including our NAT box. And I will quickly demonstrate that, and then I'll talk more about what it is doing under the covers. So after having done this change to my SSH config example, renaming it to just config, I'm going to save this file, quit, and go back to my terminal. And this time, I'll go look at my IP addresses on the two boxes. In the NAT box, I have a public IP, which is good. I have taken that public IP and put that in place in the config file here. And that is the line number 2, which is 173 at the end. If I go compare to my Amazon console, it is the same IP address, 98.173. Now I look at the other box. This box, application server, it does not have a public IP, but I know it has a private IP, and 10.01.32. That's the private IP. I will grab that and I will place that in this file in this line number 8. What these things basically do is what I'll illustrate right now. And so I will quit from here, go back to the terminal. And to illustrate the point completely and very, very clearly, I would like to delete one file on my machine. And that file is the SSH known host file. I'm going to really completely erase that file. And after doing that, you will now see that I'm going to SSH. And then this time I will give private IP address of the internal box. Again, watch it very carefully. What I'm doing is clear my screen, SSH, and then private IP address of the internal box inside a private subnet, application subnet. And this will resolve it and do in a 2-step hop in one shot, connect through the NAT, through the NAT, all the way to the application server internal to the VPC. And just watch what it says now when I press enter. I have also removed my known host file, which means I don't know any of the hosts. So the first question will be, do you know the NAT box? Because that's how it is traversing through the NAT. That's the first question. Do you know this box called the NAT, which is the IP address 98.173? Do you know this? And I will say, yes, I do. And that's how the first hop is happening. Now, as soon as I say yes to the first hop, it will then traverse to the second and ask me a second question of similar type. Do you know what you're doing? 10.0.1.32. And I will say, yes, I know what I'm doing. And then I am connected to the internal box like this. And it is an Ubuntu box. And so this is not connected yet, but it will connect. And so when this happens, you will see that this does allow me to go inside in the Ubuntu machine, which has the internal IP address of 10.0.1.32. And you can see that here. And that happened in one shot, as you saw. But two hops, so two steps, one shot, one attempt, one SSH command. And the command we used was this, just SSH and internal IP address of the machine inside. Now what's going on? Let's see what's going on. And so before we jump, I want to run this one more time. And you will see that the two questions, are you sure what you're doing? Do you know what you're doing? Question number one. And again, the same question for the internal box. They will not be asked this time because I have a known host file that knows those two machines, the NAT box as well as the internal box. And so I'm going to hit one more time, and it should go through and through the NAT and go inside to the Ubuntu box, and we have it connected. Now coming out of it, I want to examine my SSH config carefully this time, one more time. And so here is the SSH config example. And the idea here is when you type SSH followed by this this IP address, which is internal to the box, this configuration allows us to discover that this IP address is something unique in our environment, that it has a proxy command, line number 9. So through that proxy command method of using SSH, and that exact string syntax you see after in line number 9 is the magic. And so that's where it begins to look at that in order to connect to the host internal 10.0.1.32, the application server inside the app subnet in the app security group and all that good stuff, if you want to connect to that box, you need to have a SSH proxy command, which actually jumps from the NAT box. And what is this word here? The NAT word is actually a reference to the line number 1, the host line number 1. And that line is basically a reference to our NAT machine, which has its own host name as the IP address defined that we know. And it has SSH forward agent enabled. What it's basically doing is forwarding this identity that we are providing, which is our private key stored locally. We are not giving the private key to anybody, not even to our own NAT, not even to our Bastion, but we are using this construct of through and through jumping through our endpoint that we might have, our border security officer, border patrol officer. They are allowing us, because we have appropriate private key in line number 4 and we have line number 11, the private keys are placed correctly. The border security patrol officer number 1 is allowing us to go through and through as a forwarding agent using the SSH proxy command defined in line number 9, and the command invocation happens with the reference to the endpoint, the last point we want to reach, which is 10.0.1.32 in this example. Does that give you an idea of what's going on?
Yeah, but to me this seems like a major security hole. Like if you could just do this, and connect to your back-end private subnets and host through a NAT device or a NAT server, to me that's a security hole.
Yeah.
Between the security groups and
you're just automating the process.
Yeah, automating.
No.
That's all that you're doing.
So there's a difference, guys, between the two methods. There's the big difference between a NAT device and what this is doing, which is proxying, right? And I basically say this because I used to be on the attacking end of this, right? I used to do white hat hacking to traverse firewalls and all this kind of stuff. So this is related directly to that. So actually, Nilesh, I'll let you kind of explain if you want the differences between them, but I can add a little bit more from a white hat hacking perspective if you're interested in that later on.
Please do that. Go ahead. I would like to hear. So go ahead, please.
Okay. All right. So from a pure path perspective, you are doing exactly the same thing on both paths. So if you're setting up a NAT box, and that NAT box is basically netting port 22 back through to an internal system and USSH from the outside to the NAT device, and the NAT device simply passes the request through to the internal system, you're not exposing your private key because you're going from your local connection point, right? It's going through the NAT device. The private key is not getting stored there, and you're reaching your internal application server, right? So you succeed in doing what you want to do, and that works perfectly fine, even though it's true that it's not best practice, right? But just to contrast it. So now if you kind of go through to the proxy perspective, it's still the same. So from a path perspective, so you're still connecting from your source, which is out on the internet. It's using your private key that's only stored on your local host system, right? It then connects to the proxy, and then the proxy is now still connecting you through to the backend application server and not storing the private key on that proxy, right? Because if, just kind of highlight it, if a third way of doing it would be to literally set up a system on the border, SSH to it, right? And then from there establish a new SSH session yourself to the internal application server. But if you did that, that would be bad because now you actually do have to store the private key on that Bastion host. And that's not good because that Bastion host is exposed to the internet, right?
Yeah.
So if anybody can succeed in hacking that, then that private key is toast. It's available, and they can now use it to attack you on the inside. So that's bad. The proxy, though, which is this method here, is not storing that private key anywhere on that system. It's simply acting as a mediator or as a bridge, basically passing information along.
No,
okay?
I get that, but what the point that I was trying to make is that if somebody does get that key, and it can happen, they can get into...
With the proxy, it's impossible for them to get the key. The key is never stored on the proxy.
No, I'm not saying on the proxy or in the NAT system. But let's say the machine you're using to connect, let's say it gets compromised. Your local machine where your keys are stored. If your machine gets compromised and somebody gets that key, they can get into your back-end systems. Is what I'm trying to say.
They can.
Is that wrong?
Well, it depends. If you have a rule that basically identifies the source IP, and that only that source IP can get in, then that's possible too, because you can IP spoof, right? But the problem is that they would have to know what your source IP is in order to then spoof that IP, and then using the same key that they've managed to steal from you, then use that same key with a spoofed IP to then connect to that endpoint. But yeah, if they have those two things, then they're in, right? But the key thing to remember here is the difference between a NAT device that's a layer 3 device, right? Basically, the only thing that it does is it says IP and port, and that's all it knows. Source IP, target IP, and port, as opposed through to a layer 7 proxy, right? So when you're hacking, you can do absolutely anything on any port, right? Look up a tool called Netcat, right? It's the hacker's favorite tool. It's called the Swiss Army knife for hacking, right? So let's say that I know that port 22 is open, or port 80 is open, or port 443 is open, whatever. I can use Netcat to establish essentially a tunnel right through that same port. And if the only thing you have between me and you are stupid NAT devices that can only speak layer 3, and they say, well, only port 80 is allowed in, well, fine. I'm using a Netcat session, literally doing anything I want over it. I could even tunnel an RDP session through it, okay? Anything. And I can come in through that port 80. The NAT device will say, oh, this is port 80. I assume it must be web traffic, so yes, you can go through, but it's not. It's an RDP session, or it's me bringing in my hacking tools, right? So a NAT device is completely stupid when it comes to that. It's just layer 3. But if you now step it up through to proxy level, which is application layer 7 protection, now if I'm trying to come in using a Netcat session through port 80, right, providing you've got a web proxy now, the web proxy is going to look at that and go, what the hell is this? This is not valid HTTP commands. I'm going to drop it, right? It doesn't just pass it because it's port 80. It literally inspects that content for validity that it matches the protocol that it expects, and only if it's valid does it send it along the line, right, using a 2-hop kind of system. So that's the key thing, right? It's layer 7 protection with proxy versus layer 3 protection with NAT. They both work, but completely different levels of security.
Thank you. I think that was very clearly articulated. This method is not insecure, not any more insecure than any other method. That's what I would say. If you lose your private key, then you are at a loss already. And if you have already exposed your private key, like Sony PlayStation Network, big hack, right? They managed to lose the private key, and some idiot in Sony did that. And so now we have the entire database of users and their credit card numbers and addresses and everything available on the entire Sony PlayStation Network is available somewhere on Pirate Bay. And so how did that happen? They managed to lose the private key stored on some secure location internal to the company. And when that did happen, the protections available can be, now let's talk about a couple of security scenarios here. So the idea that we are dealing with right now, which is again not a best practice, is to use this NAT as a proxy agent to get inside your application server. That's what we just did, a two-hop, one-step process of doing a SSH proxy command. But again, this is not a best practice. The best practice recommended right now, I think, is using a separate host, call it Bastion, call it whatever you like, but a dedicated host for you to get in. And this is the entry point. This is your tunnel. This is your gateway to your own VPC. So you can get into the application server, and instead of a NAT, you will use a Bastion and have the NAT device function just like a NAT, and don't touch it. That's the recommended practice. And open this machine, power it on only when you need to go in. That's another security measure. Some companies do that. They power it on when you want to get in. Then you assign it a known IP or a static elastic IP. And then through that Bastion, you go in, you do your work. And then when you're done, you power it off. And keep it off until you want to get back in again. And that's another approach you can take to further cut down on ways to access internal machines. Ideally, you don't even want to go inside your machines, because in an ideal world, you want to configure your machines through automation. So any application and any stack you want to build on top of your Linux, whatever stack, that should be completely hands-free automated. There should not be a need for any developer to actually go in there after the fact it is deployed. But doesn't mean that you don't even have a way to go in there. So you keep that way of going in through a double hop Bastion method, just like this, like we just did, except instead of Bastion, I just happen to be using a NAT. And that's not a good practice, but it works. Having said, Bastion is the current recommended practice as one of the methods. There are other methods to connecting inside your VPC without even using a Bastion, which is like, Amazon provides and Google provides a direct connection method. And so you can look at that. I think there are some choices available in direct connection, dedicated connection to AWS. So you can buy that connection. If you are happening to be in Ashburn or New York, you can use these providers and they can hook you up directly. And so you can get a 10 GB or 1 GB connection. This is a better dedicated connection option. For larger companies, they can afford that. They go this route. You can also establish another type of connection I think is available. I think it's SSH. So some kind of a VPN-based connection that is also possible, then that is also provided. And so the cheapest option right now actually is to use a Bastion. Cheapest as in just use a temporary, I should not call it a temporary box, a dedicated box, call it the Bastion, and use that as a two-hop solutions like this, like we are doing right now with a SSH proxy command like you saw. And that way you can get inside your app if you need to, but in a production system, you want to construct this infrastructure, the whole thing, all of it, automated. You don't want to be going there and mucking around with the machines, because the moment you touch something, I call it dirty. And any developer touching a machine that is deployed in production should be considered dirty. And I don't want to run dirty machines in my environment at all. And so I would have the developers give me a systematic method of regenerating whatever I have in the environment that gets finally deployed in production, but then have that method of generation completely automated. So there should not be a need for any person to go muck around like this. But that doesn't mean that we don't have a way. So we do have a method, and that is this. One of the several methods is this, and there are many others, but this is the most cost-effective way that I would suggest. And when you're using a Bastion host, I would recommend that you change the name from NAT. You would change the name to something like a Bastion and use the Bastion IP address, not the NAT IP address, and that takes care of that little change. You'll also need to change the IP address here for the appropriate machine you will be using. And then you might want to actually also change the username here, line number 6. It is not going to be likely going to be EC2 user, but you might use Ubuntu as a Bastion host. And in that scenario, the name has to change here. But apart from that, and of course, your key file might change if you are in a different machine. So this name might change to something like, home user .ssh/id _ RSA. That may be the name. You might actually change these things depending on what you have in your configuration in your environment. But the construct that we illustrated just now actually works. Now, having said, I will roll back the changes I just made to illustrate that point. I'm going back to the way it was, and then exiting out, and then illustrating another point, which is traversal. So the traversal of traffic. So we were able to connect to the NAT box by saying SSH and then NAT. The name itself resolves because of the config file. And so you can just say SSH NAT, and it will get you to the NAT box. And as you can see here, the NAT machine is connected, and we can do a yum update, and it should update. You need to be root. So sudo yum update, and it will show us that it is actually connecting successfully to the internet. The NAT box itself is able to connect to the internet, download the updates for this Amazon Linux, and it is all doing it fine. And so that is beautiful. But I actually want to make sure that my Ubuntu box, which is hiding behind in the application layer. So I want to break this process. I don't necessarily update this, but just illustrating that it can. So I'm breaking it and coming out of it, and then clearing my screen, and then doing the SSH to the other internal machine this time with a 2-hop process. It will go through the NAT and go inside to the Ubuntu, and SSH identification, connection closed by. Okay, let me check my SSH again. SSH add -d, SSH add hello. What just happened? Let me check.
It's the updates that you were just running. They probably stopped the service.
I suspect that. Very likely. So let me go there. Oh, okay. I think looks like I messed myself up. Yeah, probably a service stopped. So let me go and do something about it, but fix it. So the way you would fix that is, I should not be mucking around in live environments. So let me go do a restart on that machine. Might fix. Otherwise, we'll build another NAT and just get rid of this. So networking.
The IP address is going to change.
Restart might change the IP address. So we'll fix our config file. So we'll go check the new IP address, put that in the new config, and that should be okay. So we're rebooting the machine right now, and that might give us a new IP address. If it does, that's okay. And so the idea that I want to illustrate was that once you have the internal machine, like the internal app server, that machine, we want to make sure that it is able to go out to the internet and update itself. That is a key thing, right? You want it to update. So I want to run sudo apt get and then update. And that will be possible only if the NAT device is correctly functioning, which right now it is rebooting. And so that, when it works, it will allow us to go in, first of all, and then through and through, we'll then update and check whether our machines are able to update themselves. This is critically important. This is important because sometimes you have a scenario where you might have, let's say, an application running. So you have the NAT, green color, NAT, and then you have app, and you have a user. That user comes along through the load balancer and then through the app, and then the application says, user says, I forgot my password. And the application says, okay. And in that scenario, it will put an item in the queue somewhere, some kind of a queue, and then do its thing. And then some other machine might pick up the item from the queue. And this app server, which is going to be processing your messages to send out this forgotten password, will pick up the item from the queue and start processing it. and then that item processing might require it to send out an SMTP message, basically a password reset instruction back to the user. And for that, they have to access machines outside the internet, on the internet. And so they need that ability to traverse through the NAT to the world outside so that they can then talk to some kind of an Amazon simple email service or Mandrill or SendGrid, a bunch of services available, right? So these services will operate, come into play at that time, but in order for your machine's app, this machine specifically, for them to take on this work item accumulated in the queue and bring it down, bring the queue height that you have accumulated items here, you want to bring the queue down, and the application server will then take items from the queue, process it, send out SMTP messages, or any other work item that gets accumulated in the queue, you want that processed, for which you need these machines to be able to connect to the outside internet, for which you need that NAT box alive and running. And therefore, the best practice in terms of using a NAT is actually have two NATs, 1 and 2, that fail back on each other. And that we'll cover that once we are at that point in so high availability. Let us now test whether my NAT is back up and running. So let us see if the NAT gets me in, and I am in, which is nice. Now let us come out here and then go inside to the other machine, and it is letting me into the Ubuntu box. And here, what I want to do is sudo apt-get update, and this will prove whether I can actually traverse to the world outside. Or a simple, that's one way to check. So I'm going to do a traversal, and it is trying to see if I can connect, and you will see that it does not. Can you tell me the reason why it does not?
The IP address changed on your NAT device.
Let us check. It did not.
It's supposed to have elastic IP.
It did not change. The IP address did not change. That's not.
It didn't change. Okay.
The reason is that our security groups do not allow traversal. So we have to open up our security groups. Our application security group is very strict. So if you look at the application security group here, right now it is called AppSG, and let us go examine what that does. So I'm going to click on this, and the AppSG basically says, from an inbound perspective, anybody who is on the NAT can come in. That's the inbound rule. But outbound rule, let us see. All traffic go anywhere. That's beautiful. But now let us see the other group, the other security group, which is, does NAT allow me to come in from application security groups? So inbound rule for NAT, we need to expand this, edit, and allow all traffic as long as it is coming from, so do it again. Allow all traffic as long as it is coming from my app servers. You see that? That's what I'm doing. That I need to do this. Otherwise, my NAT security group will not let my applications connect to the world outside. And that is the step that I need to do right now, is to allow anybody in the app complete traffic and save. And if I do that, then you will come back here and you will momentarily see that this connection will succeed. And so you will see that happening. If I break it and run it again, this will allow us to go outside, and apt-get update will actually succeed because we have just opened up. In fact, it just did. On its own, it is taken up and it started flowing the traffic, and so it's going to bring down all the updates, and it just did. It fetched 10.3 MB in 2.4 whatever minutes. So this succeeded because it was waiting on us to allow us from the NAT security group. Let's go examine the things that we did. So in the NAT security group, what change I just did was that I enabled inbound access to the NAT, as long as, so go back again here, and inbound access to the NAT. If you are in the application security group, you can come into the NAT security group. So that's the scenario. And that's what I'm illustrating here, is that we want to be able to allow our machines that are inside, have these guys go and approach the group known as NATSG. For an inbound perspective, allow that if it is coming from the AppSG. And that is the rule that I had to open for my machines in this group to go use the NAT and go out. And then this apt-get update succeeded. Without that opening up, it will not. So you have to allow basically NAT to receive traffic from app and let it go. And so outbound rules are very lax. So if you go check, we have our outbound rules are very open. So all traffic anywhere, go whatever you do feel like. However, for inbound, we have to be secure and limited. So for NAT, we are allowing traffic. I think I'm the wrong VPC somehow. I'm thinking it's the wrong VPC. Is it the wrong VPC?
I think so.
I don't know. I want to look at let me refresh. I think it is not wrong. Maybe I'm just confused. Inbound, yes, it's okay. So it is the right one. And the key thing that I'm illustrating is that we are allowing this traffic. So it goes like this, and also allowing us to go in from our current location. So we can go traverse from 422 and in a 2-hop scenario, go to any machine inside. That's the quick step we did through help of this configuration example. And that's the way to assemble. Now let's do one more thing, which is you will see the problem when I actually kill my NAT. See what happens when I have my NAT and I just decide to terminate and say bye-bye. And then I cannot do anything. Basically, I'm stuck. My connection is broken, and I cannot access my own internal box. And also, one more thing you will see with this broken situation is that in our VPC, in our route tables, which is here, in our Kumo VPC, in the application subnet, and the route table corresponding to the app subnet, we will soon have a black hole. That black hole will come because of the fact that our NAT is dead. And so this should show us a black hole right there. And this happens because our NAT died. So our machines that are in the application subnet do not have a route to the internet, the 0000/0. They still have a route internal to the VPC, but they cannot go outside. It's a black hole. The black hole is just a nomenclature that Amazon chose to use, but basically there is no route. So if you try to edit that, it will have to be removed. And if you try to add another route, the only route you can actually get to the public internet outside is the gateway, because the NAT is gone. And so without that, you cannot even save, because I don't want to save this one. I do want a NAT, so I will have to bring the NAT back. And that's the only way to come back to life for those internal machines, because that's where NAT is super critical for any application that you want to deploy internal to a scenario where you have a VPC defined and you have your internal subnets defined, like application subnet or some other database subnet or some other queuing subnet or Mongo subnet, any number of subnets you can have internal, and then you have your border subnet outside is the scenario where you have to have that NAT box sitting here and alive and responding to these guys so that they can traverse outside through the NAT. And then you might have load balancers and other machines functioning on the border subnet itself that will directly connect to the internet, no problem. And so does this NAT. Now let us describe this slightly varying idea of the same concept in HA scenario. So the high availability scenario now. The scenario is that you have to have basically the same thing duplicated, at least duplicated. You can have multiple, but at least two. And that brings high availability concept in simple terms. What you would do is you might have a border checkpoint subnet and another border checkpoint subnet. By the way, you would keep these two on two different availability zones. And in Amazon or in most cloud providers, they will give you these 3 or 5 availability zones. Sometimes they call it, let's see what the name they use. So in the example we have here, let's start a machine out there, launch an instance and get the NAT back up and running. So we're going to get the NAT box created. So we have this machine I want to use for NAT. And so I'm going to select it, and then I configure, then I configure my Kumo, my border checkpoint will get it, and then I enable my public IP. I'll assign it. manually assign, automatically assign a public IP, enable it, and then I go add some storage to it, and then I tag the instance as NAT, and then I configure my security groups, and I can select my existing security group, by the way, which is going to be NAT, and then I review and launch, and then when I launch, actually I should go previous and illustrate that point which I was trying to illustrate, which was that you need to grab the, where is that? I want to select a particular, oh, it is not there yet. Okay, hold on. It is not there because we have to actually have different subnets in different availability zones already. Then it will show up. So like for border, you will have to first create 2 distinct subnets, and so for app, and so for DB, and so for any other role you have. So for every role, you will create at least 2 subnets in availability zone 1, availability zone 2. These are basically different buildings you can think of. One building in Oregon, another building in Oregon, one building in Virginia, another building in Virginia. And so that's the scenario in the context of an availability zone that Amazon does provide you up to 5, 1, 2, 3, 4, 5. They call it, I think, A, B, C, D, E, if I remember right. And so you want to have 2 for each, 2 subnets for each kind of function that you might have in mind. So a border function, an application function, database function. For every function, it is ideal to at least have 2 distinctly different subnets. So what I would now do is actually go back to my subnet creation place, which is back in my VPC here, and I will rename my subnets that I have. So I have the Kumo, and I will rename this border subnet. I will call it my border E. And the reason I will choose is because this E has been given already. So I'll choose the E name because that's the name they have assigned to my availability zone. So I would like to name it accordingly. And I will rename this as border-E and then save. And let us check this app subnet. Let us see what they have given in terms of availability zone 1E again. So I will rename this application subnet as my E subnet. And now I will create 2 more, at least 2 more. And here I will choose deliberately, I will call it my border A, and choose my Kumo. And here, instead of saying availability zone no preference, I will say I do want to prefer A. And then I can assign a CIDR block. In this example of CIDR, I have a convention that I have set for myself, and I will illustrate that convention in just a minute in a white sheet of paper. The convention I have chosen is that I like to do for, say, border, for at least 2 different subnets, I would like to use this range that I have already used in the previous case, 24 here. And for a similar analogous example, on the application subnet, I tend to use these numbers for a convention. Again, this is just a convention. And so that becomes one of the subnets in the application example. So here I would like to change it to something like this number. I will change to 10.0.10.0/24. And this number I will change to something like 10.0.11.0/24. And so if there are more subnets, like a database subnet I have, I might choose something like 10.0.2.0/24. And correspondingly, the other subnet would be 10.0.20.0/24. This is just my convention, and it's easier for me to just tell by the IP address as to which subnet this thing is. And that is just a focus on this third byte in terms of naming it or numbering it, so that I can tell just by the number what am I dealing with. And that's just a method that I like to use in terms of carving out different subnets. And you can apply the same concept to any kind of a layout in any environment. And the idea is, it is not specific to Amazon. You can do the same thing anywhere. And so the idea is to have this last digit kind of indicate where am I, or you can make up your own convention. So right now I am going back here and putting a subnet of 10.0. This was 10.0/. 24. And that's the section I would like to pick. And this time I'll go in the A, border A, as in US East 1A. That's where the name A comes from. The previous one I have already been allocated when I did not choose any preference was E. That's what they gave me. So this time I'm going to the other end and say A. And I'll say yes, create. So that will create a new border subnet for me to use in the border checkpoint, which will give me basically two redundant subnets where I can allocate my NATs. And so one of my NATs will be in one building, the other NAT will be in the other building, both of them in Virginia. And that's our scenario from a NAT perspective. We'll putting these border boxes there, border subnets there, and then the application subnet, very, very similar, app A, and then Kumo, and then selecting the US East 1A selection here. And our name convention was 10.11.0. So we'll just choose that name 10.0.11.0.24. And that's how you will construct this app A in the US East 1A as a redundant subnet for your applications. And now you have two of each. And so now our drawing on the chart became a little bit more complex. And the complexity is now that we have two border checkpoints and two app subnets. One of them is A, the other E, one is A, the other is E, and this is border, and this is app. And so basically you're doing the same thing twice. And you have an ad box here and an ad box here. You have machines sitting here, and you have machines sitting here, and they will be all separated. You will load balance them, meaning you will put one machine here and one machine there, and have the load spread out among these two different subnets that you have in your application collection of machines. And that's how you would like to divide your work in terms of what you are dealing. And you will also put a rule around your NAT devices to function like a takeover. If one goes down, the other one allows the traffic to go. So you have machines that are traversing through this NAT. If they find that this NAT is dead, they will automatically route traffic through this NAT, and that scenario can be enabled programmatically. And that's the construct we are basically illustrating in terms of what you can do. So now we have 4. So we can now go back to the creation stage and then start creating a NAT. And when you do that, it will allow you to select the appropriate subnet you want your NAT to become a part of. And so NAT instance launching now, community AMI, NAT selection 2015, select short list of 3 machines, select the second one, and then go next, configure details. Here you select Kumo. Here you have the selection between border A and border E. And you can select which NAT, this NAT goes where. So this time you can select any choice you want to make. You can say, I want it in US 1A, US East 1A, so border A, that's where it goes. And I can select an IP address to become available. So I have an auto assign IP address, then I can proceed to add some storage and get an SSD, and then tag the instance, call it my NAT in the A region, and then configure my security group. The security group I have already set is NATSG, review and launch, and off I go. And so I can just acknowledge that I have the key pair and launch the instance, and my NAT is up and running, but it is still not behaving like a NAT does because of one thing. It still does not work like a NAT. And that one thing is that you have to right click on the NAT and make sure
source destination checking disabled.
That's right. You have to disable this part, without which NAT will not function like a NAT. And so you have to remember this. When you're dealing with like first few times, you tend to forget, and then hey, it doesn't work. What's going on? So disable it, and then when the machine boots up, you have to grab this public IP address, which is now different, expected, and you have to put that back in your SSH config like this, and delete the old one. It is dead. You have to put the new one, and it is good. And then you have to make sure that you knock down your known host file, the particular entry for that line number 2. That has to be knocked down, otherwise it will cause conflict and it will not allow you to work. So I'm going to just, for the sake of convenience, just remove the known host file. So rm known host file gone, and I'll say SSH the same way, 10.0.132. Hop one shot in 2 hops through the NAT box, through and through to the app server, internal, go. It will ask the same 2 questions. You know what you're doing, right? The first one, that's coming up. I think our NAT is still booting up. I was in a hurry to get it. Our NAT is still probably booting up. So I'm going back, checking, see it's initializing right now. So it's not ready for us to listen to. And so it's not going to listen unless this initialization finishes. And it's still initializing. So yeah, I need to be patient. And so when this gets ready, we should be able to go through and through hop in one shot, reach this box, which is the 10.0.132 machine we have inside. That should be totally possible. And so the reason I am bringing this up is that we have this granular way of clear understanding what components we get, what networking gear. We are literally putting networking gear together in assigning, assembling our subnets, putting machines, putting NAT boxes, and carving out a secure area for ourselves with appropriate keys in place, ports open, and carving out a blueprint for our own private cloud. You can call it a virtual private cloud, or you can bring it locally to your building and call it a real private cloud. It doesn't really matter. The concepts are identical. The same thing applies in any scenario, whether it's Amazon or not. That's irrelevant. We just took the Amazon example because it's readily available for all of us to look at and work with and play with. You can do the same thing in a real life environment with appropriate gear and carve out the same construct that you have in your hand. So I'm going to refresh, see if I think succeeded in initializing finished. Why is it so slow? Because I'm going to be a cheapo right now. I know it's slow. It is slow because we are using T2 micros. That's why it is slow. By the way, T2 micro machines do not get much priority above any other machine. It is actually the lowest priority machine you can get. It is also the cheapest. And that is why sometimes you get this. And I don't like that. But that's...
While we're waiting for that, Nilesh, if you want. Just to add something here, that I'm surprised that it's not taught in normal courses. I'm not referring to yours specifically. I'm just talking about generic security courses or TCP or networking courses and so on, right? Which is an important thing. It's like knowledge that's only taught to hackers, which is ironic. But does anybody, just to kind of make it a bit interactive, does anybody see any issues with what is being done here in terms of access, just to keep it generic? Purely from a security perspective, I'm talking about, right? Any potential issues? No? Everything looks good? Okay. All right. So was everyone clear on
the access?
Yeah, there's a hole here, which again is like stuff that hackers know that most other networking people don't, right? But this type of scenario that's been configured here is extremely common, right? So what I'm referring to is that you have, level 1 companies that don't know anything, that basically just use a NAT device for inbound access. And as I explained before, a NAT device is completely stupid. It's just layer 3, so I can do anything on any port, right? So that's bad. So then you get the next progression of level of experience, if you like, of companies, which is they say, oh, okay, we have to put in proxies for inbound access, not NAT devices, right? So that we now have layer 7 protection instead of layer 3 protection. Okay, that's good. But hackers are, they'll basically attack the weakest link. Okay, so if you have, and I've literally run against this myself, like customers that had put in $50,000, $100,000 into configuring their firewall and all this kind of stuff, right? It's like super, secure and all this kind of rubbish, right? So they say, okay, great. And they may have been using, let's say, layer 7 protection for inbound access, right? The problem is that then for outbound access, people do what you see here. For outbound access, they say, well, we want to let people browse the internet and, send email and, all that kind of stuff. So, port 80, off you go, through a NAT device on the way out. Okay? That is actually a huge hole. Okay? Here's why. The reason is because when you establish a TCP connection, you go through a 3-way handshake. Okay? That 3-way handshake establishes that connection, but the emphasis is on the establishment of that connection. So in other words, there is a source, and there's a destination, and there's a port. Those 3 things, right? So when you're connecting and you're setting up filtering on that for outbound rules and all that, that's the only thing you're saying. You're basically saying everybody on the inside can connect to everything on the outside on port 80 and port 443, okay, to allow them to browse websites, okay? here's the problem. The problem is that once a TCP connection is established, that becomes a virtual circuit that allows bidirectional communication, okay? Not just one-way communication, as everybody thinks. The rules that you specify in an outbound firewall rule set are directional, but that's only to establish the connection. After that connection is established, you have bidirectional communication, right?
Yes.
That's really important to understand, right? Because what happens now is that all I have to do is not attack your servers, because they're probably pretty well protected. I attack the weakest link. Who's the weakest link? Joe Smith running on Windows 95. Okay? Some workstation that's completely outdated, whatever, right? All I have to do is to get Netcat onto his system.
That's right.
Right? Which is a piece of cake to do. There are many ways to actually get that on there. Basically getting them to connect to one of my websites, which then has, malicious content on it. I can then automatically get Netcat downloaded to his machine. So he's established the outbound connection through to my malicious website. My malicious website now puts Netcat onto his system, right? Now his workstation can establish a brand new outbound connection using Netcat, right? What port am I going to go out on Netcat? I'm going to go out on port 80 or port 443, okay? So when I go out on port 443, connecting now to my other malicious Netcat server that I control, right? That internal user happily goes through NAT. The NAT says, what are you trying to do? You're connecting from the inside to the outside on port 443? Sure, go for it. Have fun, okay? That connection goes through NAT, but it's using Netcat, right? It's going out through my Netcat server, establishes the virtual circuit connection now, and now, believe it or not, I have a bidirectional SSH equivalent connection from my server to that internal workstation. I am now inside your network, and I've sliced through your firewall. Okay?
Yep.
Once I'm there, you are toast. I'm on the inside. I'm now hacking from the inside, which is a piece of cake. I can do things like redirects. I can attack. I can even, for example, I can do like an RDP proxy via Netcat to attack your Exchange server. So I can now do, terminal server session via this Netcat tunnel, which connects to this internal workstation, bounces me then through to the Exchange server via RDP. And I'm now literally terminal servering into your Exchange server on the inside. Okay? And that entire thing was brought about because you've got a NAT device allowing outbound access to port 443. Huge hole, right? But again, it's for some weird reason, this kind of stuff is not taught in conventional networking or security courses, right? It's just taught to hackers. Hackers are the only ones that know this stuff, which is weird. But be aware of that, okay? The golden rule for security is nothing is allowed in or out directly without going through a proxy. Nothing. That's the ideal.
From the security white paper on Amazon, you're not supposed to be using a NAT device to come in. You're supposed to be using an ELB so the ELB can do what you're talking about.
I'm not talking about coming in. I'm talking about going out, Carlos.
That's what I was going. Because it checks the connections going in and out, and it can actually truncate the connections that are incorrect.
Hey, Carlos, the ELB is basically allowing inbound traffic on port 80443. It doesn't do this.
You can put any port that you want. You can even load balance the SSH connection for your host, for your Bastion host.
Yeah, but you wouldn't be using it for outbound connections for allowing your internal servers, let's say, to connect through to any like Microsoft.com.
So what Ron is suggesting is outbound access, and what Carlos is saying is inbound access. So two different things, right? And so Ron has a very valid point, and it is like weakest link, and that is one of the things. You have a weak spot, and that's where you inject your malicious software inside. And so once that weak entry, you take over that thing, then inside that VPC or any kind of a private setup, you can then through that hop that you establish. So a simple way would be like Windows 95, you malform JPEG on a browser, you can inject some bad code and have that weak link exploited. Once you have a handle on the exploited machine, this machine being internal to the cloud can actually have unfettered access to anything on the app server, database server, whatever you allow. It will have access to anything internal to you. And the hacker here, the bad guy, this can basically create and manipulate your weakest link. Once they are able to exploit this guy, the whole thing is basically dirty. And so I don't want these guys inside the VPC. That's one of the reasons why I said, always configure your infrastructure in a fashion, even though it happens to be in a private cloud. Don't assume that it is going to be foolproof and secure proof, because you want to actually take care of the weakest link and make sure everything is hardened. And don't even allow access to people even on your team to just go muck around with your machines. We don't want a Windows 95 inside a VPC, by the way. And so you don't want.
The thing is, you're right, Nilesh. The thing is, that's only half the issue that I'm talking about. The issue that I'm talking about is that from that machine, if you can go out through a NAT device, you have no control of what will come back in.
Correct.
Even though you've got firewall rules and all that kind of stuff in proxies for inbound access, like you here have set up an SSH proxy, which is great, okay? But if I hop on through to any one of the systems that's allowed outbound NAT access, and I basically figure out a way to get Netcat onto that system, I can then connect via Netcat outbound to the internet on port 443, connect to a Netcat server. At that point, that system, I can do anything that I want over that virtual circuit. I can do SSH, I can bounce off that internal workstation to any port, to any internal system of my choosing.
Yes, indeed. If you have your agent inside, this is like, in mythology, in Indian mythology, they have this thing called agent inside. And that's the hack to, some big stories. Like epic in India, in Hinduism, in which this exact problem is illustrated with you have an agent inside in the enemy's territory. You are able to go exploit that. And basically, if you have that exploited agent, this exploited machine that you have, if you have provided it with access to a TCP tunnel, a regular TCP tunnel, you can masquerade other type of traffic on top of the tunnel and do whatever you want. And that is a risk. If you allow that thing to go out, this is very common in corporate settings, right? That's why these IT people in big companies are paranoid in terms of making sure that your machines are patched and up to date and all that good stuff. They regulate you through Active Directory and group policy rules, and the entire corporate network is basically sniffed for any activity that may be malicious. And you might have corporate cops coming at your door saying, you seem to be running this software, we don't want you to be running that. That happens all the time in big companies, right? So you might have seen that. That's exactly what Ron is illustrating, is that you have a corporate network, which is like an island. And so you have an exploited machine internal to that machine. And once you have that and hacker has a control of that agent inside, they can do whatever they want in your corporation inside. You can go random access to machines internal to them and elevate privileges on other machines and have basically muck around whatever they feel like. So that is something that IT people are super cautious about. And that's one of the reasons why this idea of domain control, least user privilege, and group policy controls through corporation, and that some companies do not follow, but then other companies are very rigid about it. Like for example, Boeing, right? It's so meticulously done, is that Boeing people cannot even install VirtualBox software that I provide. So poor guys, they actually bring their own laptops and home laptops, and they're working on those home laptops to make use of this program that we are dealing with. And that's a fact of life. Boeing does not allow you to run any third-party software unless it is completely vetted through. And so that whole is what they're trying to cover and address, is to prevent these hackers from running bad code inside. And that may sound like some Boeing people actually complain about this, that their IT doesn't let them have admin privileges. But I think there is a security trade-off that company has decided, and that's the company policy that they are honoring by. So that's differs from company to company. Like in Microsoft, when I was there, we used to set up our own Windows every single day, right? I used to be in the Windows Server division, so every night we'll have a new build of the server. And so that's a different game. But then most corporate employees are not like that. Even in Microsoft, it is very regulated, structured. But developers will do whatever they want, and that's a need. It's a business need. But they need to be able to give that permission for them to deploy their own binaries every night. So nightly builds and all that good stuff. So that happens. But very valid
It's
point.
pretty simple to shield from, though. All that is required is just to do proxy level access in both directions. So basically, never use NAT. Proxy for everything.
Correct.
Right. So, for example, if you want to browse the internet, don't browse via NAT. Browse via a proxy server.
Yep.
Right.
Server and filter it.
Squid or something. Right.
Yep. Filter your traffic. You want to filter your traffic, and some companies actually put other types of filters, like they will prevent P2P connections, they will prevent other types of connections. Some companies even prevent Skype connections, and that's just a company policy. But yes, it's a valid scenario where you want to have some kind of a border protection method beyond just simple NAT. Most smaller companies tend to go just NAT, but you want to go elaborate on that and be more religious about what kind of traffic you actually go packet level inspect as to what traffic is flowing and go some analysis on what traffic is actually happening. Identify what may be a sign of something bad and promptly alert your internal staff to go take care of that. That packet sniffing happens in most cases in large enterprises where the need is critical. But if you're really a small entity trying to experiment or pilot something out, probably it's not that big a deal. But it's really a trade-off as to, you want to go proper way of doing a final production deployment versus, putting a proof of concept together. It's something that you need to worry about from a security standpoint. It is absolutely important to not just use a NAT, and by the way, using NAT like I just did is not a good practice at all. You don't do that at all, absolutely. But this is just an illustration that you can. And similar to that, you will also have a separate machine that you go through in, like a Bastion host, another host. Call it Bastion, call it Tunnel, call it whatever. But that will allow you to go in and operate on a small blueprint that you want to create. And from a deployment perspective, of course, like Ron mentioned, that is absolutely required from a large-scale deployment perspective. From a company who has money, will spend the money rightly in that direction.
The thing is, you can deploy something like Squid, which is free.
Right? Yeah, correct.
So you don't need money to be secure.
Yeah, yes, indeed. Yeah, Squid Cache is beautiful cache. If you're not familiar with Squid, here it is. Squid. Squid is built into some routers. Some NAT devices will have Squid already, and not this Squid. It's really the Squid came along. Squid Cache, I should say. Oh, no. Squid. Why can I not type properly? So Squid Cache, this one is actually a free open source product, and it is available as a part of NAT devices sometimes, and it automatically by default is activated. So all you need to really do is apt-get install Squid, and that takes care of most of the problems. It also speeds up your HTTP downloads or repeated access. In fact, a scenario that I find it most interesting when people are demonstrating, let's say, OpenStack deployment, and you carry along this orange box. I think I illustrated this orange box. Ubuntu is a good example where you take this box. It has 10 core CPUs, and it has a built-in proxy cache, Squid Cache already. And so what you do in this machine is that you take it to a customer and have them deploy OpenStack in this Ubuntu Orange box, and the apt-get updates and all the installations finishes so quickly, because if you do it already once before you go to the customer, the Squid Cache on the box itself caches the whole apt cache. And so your apt-get update, you can actually finish off and deploy a complete OpenStack on this box using a cell phone data plan. And that I've done people do that successfully in a demo situation. This is not a production machine, but a complete production, complete deployment of an OpenStack from bare metal all the way to bringing up nodes on this orange box with 10 CPUs in the rack. It's a little portable. So you can actually finish that off. If you have it done once already with a wired connection, Squid will cache your apt cache and have the entire OpenStack environment up and running with bare minimum, like a phone-like Wi-Fi data plan, tethering plan. You can finish that off. So caching helps in both ways, not just providing protection, but also actual caching and speeding up your connectivity. So this is a good software. Only one simple command is needed to make it get to work. So very, very simple. And it is also built in many routers. Like you saw the router that I was showing you. This router sometimes has built-in squid caching. This software is open source. It's DDWRT, and it has a iteration that comes with squid caching built in. And that is one application that I like to use in my routers. This basically makes your $100 router a $600 router, a Cisco router, high end. And another iteration is this Tomato, or yeah, that is another router software. Open source again. It also has caching and VPN and all that good stuff supported. And I think you have to configure the proxy for this guy, the Squid proxy, Squid cache for this guy. So that was nice discussion. Thank you, Ron. Thank you for that. And this is Netcat. There's another tool that I think Ron will know about. That tool is called Nmap. Nmap. Right? You know what this thing called Nmap, right?
Nmap, yeah. Yeah, you use Nmap to port scan and drip feeds,
right?
And then Netcat to attack.
Yeah, exactly. So Nmap is beautiful. You can scan the entire internet for every port you like. It takes a long time. But in University of Michigan, they have come up with this thing called ZMap, which is, I think, a little bit more beautiful than Nmap. And by the way, this thing completes the entire scanning of the IPv4, entire internet, 4 billion addresses in about 45 minutes. And so that is a good software, again, open source, ZMap, University of Michigan. That's my university. And this, you should take a look at this if you haven't seen it before. Open source network scanner, ZMap. So in earlier discussion, I think Carlos mentioned this, right? Terraform. And I think it's a good tool. Did you see this one, Carlos?
Dilesh?
Yes.
Is there anything you want to hit as far as free work for next class?
Yes, I want to hit this point exactly. What I'm trying to build up is Terraform is conceptually a similar thing to what you have here. And so what I want to actually cover is this being able to create a blueprint of a set of resources. So for example, the idea I want to discuss is this thing, which is called CloudFormation. And I'll paste a link for you guys so you can read more about it. And this is a tool available in this location, which I just gave. And that tool allows us to do two broad things. And you can read more about CloudFormation in Amazon's documentation and also on the link I just gave you. And the idea is once you create your subnets and your machines and the whole design is ready, right? You have your border checkpoint subnet and your app subnet and machines and NATs and everything is all ready and good. It is quite boring to repeat the whole thing over and over and over again, right? And so there is this method of creating a JSON file and out of the existing design. So you design something by hand and then you create a JSON. And a flip of the same idea is you take that JSON and apply it to a cloud. And when you apply, it will create that design based on the JSON you provided. And this is the core idea we want to go next time. And the idea is you convert a design into a JSON object, a JSON file, and then JSON into a design. And this conversion is possible through an Amazon tool called CloudFormation. I just gave you a link. And that is also the same idea behind this tool, which we briefly used in a previous example on the other day. And the idea in this is that this is agnostic to the cloud provider. And you can basically run this command called terraform apply. And we did the other day, if you recall. And it will build out the infrastructure you want as defined by the configuration you are trying to apply. And this is very, very elegant, very, very simple tool to use. But the core idea is, as I just said, from design to some piece of paper, and from piece of paper to design. And implementation, actually, it's implementation. Not just design, but implementation of the design and its implementation. So from implementation to paper and back, that transition, the traversal, happens through this tool set, which is available in Amazon by this name called CloudFormation, where you get to create a template from your existing resources, or otherwise you create a stack based on a template you provide. So it's both ways. Both ways are possible. So we'll use both these exercises and also compare and contrast with this open source tool we have here, which is Terraform. And this is something that I think is a very elegant reading, and the documentation here is nice. I would like to have you take a quick review of this. There are some providers available. So if you click on the documentation button on top and then click providers, that's the area you should read. And look at the DigitalOcean example we tried the last time. And also look at the AWS example, also provided on the same side. That's a very, very simple read for you to just understand what this is going to be doing. We'll play some scenarios of this, as well as the comparative comparable that we have, which is CloudFormation. So CloudFormation is dedicated just for Amazon, but Terraform will do similar things, apparently similar things with other clouds. And that's the discussion for next time.
Okay, so just to be clear, you're saying that they're different tools, or is the CloudFormation from Amazon just a rebranded Terraform?
I think Terraform came later. So
okay. So the competing products.
Yeah, they're you know, I don't call them competing, but it's a different. They're not really superimposing. You know, it's very unique to Amazon versus this is more general purpose. There are limitations to Terraform. You cannot do certain things. It is still under development. It is new, but promising. A very new tool, actually, Terraform is. So it is.
I'm assuming that Terraform is something we could use for our private clouds with private infrastructure, as opposed to CloudFormation, which is only on Amazon, right?
Correct. Yes.
Okay.
In fact, if you can look at this in your Terraform, there is an OpenStack implementation probably also available. Let's go to the documentation, providers, and there is OpenStack. And so here you have all these capabilities you can enable in OpenStack through Terraform. So once you have OpenStack infrastructure ready, you can use Terraform with OpenStack provider like this and do it yourself on your internal locations. Don't have to rely on the capability like Amazon does, but do yourself.
Okay.
Some things are possible, some are not. So we'll understand what is possible. And this thing is actually evolving, so it's available on GitHub. And you can read more about it. Lots of commits, lots of contributors, very popular project, and lots of forks. So you will not go bad with using this. This is extremely popular and evolving, and that is something that these numbers that you see, star and forks, are a good sign of a good project. How many branches, how many commits, who are the people behind it? All of that matters, and the 255 contributors. So it's a good sign already there. It's a good product. That's what I'm saying. And it is, it's going to evolve even further. It will help.
Okay.
Okay, sir.
So we're done then? Yep.
Yeah, I think we're good. Let's meet again on, when do we meet again? Monday? Yeah.
All right.
And David should update you on what we just did. You must have received emails. So at least the Hitachi guys must have received an email from system. Each one of you have received 3 emails from apparently me, but I'm asking a machine to send you. So some system will email you 3 emails per person for each one of you in the Hitachi team. And David,
are you saying that that's already been sent out? Because I'm not seeing anything.
Already sent out. If not, I will double check and send you manually also. So
I haven't seen them either.
Oh my God. I think I almost did that after I spoke to David. So let me then manually copy and paste and send you in Slack chat. I'll paste a link that will also show you the same thing that you were expected to receive in email. It must have gone to junk or something. So I'll fix it in Slack chat.
Just the email is fine.
Fair enough. So I email and I give you links to where you can click and do the next step.
Okay, that works.
Thank you.
Okay, I'm headed out. Have a good weekend, guys.
Yes, sir.